Cody, no one wants to sit next to you. You're scaring people out. Well, the intimidation ended. Someone. Yeah. I'll be here.
I see. Good morning, everyone. Good morning. Welcome to BSides Las Vegas. This talk is Painful Learnings of Applying AI in Security, and we have our speakers today, Anton and Chris. We'd like to thank our sponsors, especially our diamond sponsors, Prisma Cloud and Vanta, and our gold breaker, SEMGREP. It's their support along with our other donors, sponsors, and volunteers that make this event possible. For cell phones, these talks are being streamlined live, except for Sky Talks. And as a courtesy to our speakers and audience, we ask that you check to make sure your cell phones are set to silent. If you have a question, make sure to point at the mic in the audience to the audience so that the people know where it is. Okay. All right. Thank you. And here are our speakers.
Hi, everyone. Happy to be here to do the first talk. Kirill and I, it's the first time for us in BSides Las Vegas. We did give talk in other BSides and other places, but I want to do a first intro kind of contract between us and you guys. We will share the slides later if anyone wants. I just rigged it a little bit before the session, so I need to redo it and upload to SlideShare and share it. If at any point you feel that it becomes a product pitch, we say mob too many times because that's our company, boo us, okay? Loud, like boo, something like this. Yeah, exactly, right? This is not the point, right? We are not doing a product pitch here. We're going to talk about our research, about our work, what we did. If you later want to know about it, of course, we'll be happy to do that. If you like it, let us know. Take pictures, post on LinkedIn, make it fun. And let's start. So a little bit about myself, and I will say ahead of time, it's weird for me to stand here, stand still, but I can't take the microphone, so it will be weird. I was born and raised in Israel. If anyone has issues with it, sorry. I live in Massachusetts since 2016 with my wife, three kids, 3 dogs. Sadly, 2 dogs since 2 weeks ago. It is sad. I used to run long distance, but if anyone here knows the weather in Massachusetts, you can't run the entire year. So half a year you're running and then you lose everything. And I'm in the AppSec business since 2007. I was a developer, turned to product manager, and now I co-founded and I'm the CEO of Mob. If you want to connect with me, I'll be happy to, as long as you don't send me spam and BDR stuff. And Kirill?
Yeah, hello everyone. I am really happy to be here. It's a huge, it's very, very good. I enjoy it. And thanks a lot for coming here. So I was traveling around the world for the last 10 years, and I am over the 15 years in security and software engineering. Currently, I live in Amsterdam with my wife and 2 kids. And please make some noise for my wife. She has a birthday today. So while I'm speaking here, yeah. And I am a co-founding engineer at Mob, so I'm leading the security research team there.
We need to drink for that tonight.
Yeah.
Okay, so we'll start with the agenda. We have a lot of slides, so I don't expect you to take pictures. Again, we will share all those slides. If you want to take pictures of Kirill. It's better. We are going to talk about the problem. What is the goal? What we were trying to solve with our research. The different steps of how we attacked it. How to not use AI. How to maybe use AI. How to, we can do the work without AI. And then the mix that we believe is the way forward. Now, from our perspective, yes, startup these days, everyone needs to say AI. AI was never the goal. The goal, if you want to solve a problem, it's not AI. The AI is maybe a way to get to that goal, and this is how we treated it. So everyone knows this one, right? The lovely DevOps infinity loop that security vendors also want to say, hey, this is DevSecOps infinity loop. But from my perspective, DevSecOps is broken. And why DevSecOps is broken is because you may have integrated security scanning into your pipeline. You may be scanning on every commit. You went all the way in the ID. Are you actually fixing anything? Most issues that are found are being kicked off down the road like an old can and are not addressing. And the reason that I'm saying DevSecOps is broken, because the goal for DevOps was, can we release product to the market faster, higher quality, everything best. Let's ignore CrowdStrike for a second, but it did prove itself that it works, right? If DevSecOps was the same idea of delivering secure product quickly to the market, I don't think any of us made it, because we find vulnerabilities faster, we're not fixing them, so why wasting the money? At the end, we get to something like this. All those issues that you didn't fix are piled up, and I'm working with some companies that have hundreds of thousands or even millions of vulnerabilities in their backlog. Why? Because 10 years, 15 years, they didn't fix any of them, and now they can't, right? You need to come with a D9 and clear all this mess. So this is the problem. And this is the most wordiest slide I ever had here, so don't be worried. The idea is there is so much work to do, so very much work to do, and people can't handle that, right? They cannot. Over the years, they decided, okay, we can't fix it, so we won't fix it. So what? Nothing happened yesterday, nothing will happen tomorrow. But there are winds of change. And software supply chain is the thing. If I'm a software provider and I provide my software to another company and they provide software, any vulnerability that I have in my code are now their vulnerability. We are running on AWS. If AWS has a vulnerability, that's my vulnerability now. And the industry understands it. Between this and PCI 4, by the way, that next year will be mandated to fix stuff, yeah, you can't just sit on your hands and not fixing things anymore. And that's what we were trying to do. So our goal was to create automatic first-party code fix. We're not talking about third-party, not upgrading your library. The code that you actually write, that your developers write. By the way, any developers in the room? Nice. Security people? What else? Any CISO in the room? Okay, we'll go to talk to you later. So what we were trying to do is basically minimize the mean time to remediate. You see researchers, Veracode and all that, 3 months to fix an application security high severity issue. I mean, 3 months, that's crazy. Can we do it faster? That was the first goal. Second goal, we're developers in nature. I mean, I used to be, Kirill still is. We want to help developers get rid of that security problem to focus on what they love best, what they were hired to do, right? Build cool stuff. We want them to build cool but secure stuff, and we want to allow fix at scale. And this was the hardest challenge for us. Can we actually allow a company, let's say a big bank has thousands and thousands of SQL injection. Yes, they do. If you don't know, they do. I know. Kind of scary. I know someone can get all the information easily. But this is what we're going to focus on, because the other issues are hard to measure. And how we're going to do that in this session? With AI. Who is old enough to recognize this guy? Cool. Okay, back to Kirill.
Okay, when we are talking about AI, first thing coming into our mind is basically generative AI. Today is the narrative, right? Like you have all these ChatGPTs, Gemini, all those models, a lot of them. And like a lot of people say they really performs great on such tasks. So first thing is very, very naive approach, which we also implemented to do our research and try it. So the naive approach here is like you have basically a template of the prompt. And in this template, you basically have keywords, right? Like I have XSS vulnerability, like XSS, you put the vulnerability you have. In the following JavaScript code, so here's TypeScript, Java, whatever you use. Then you have the triple backtick and you have the code sample, the vulnerable code sample. And the vulnerability is in line, the line of code, fix it. Like fix it as ask for LLM to do something, right? And here on the screen, you can see like very typical XSS injection. It's reflected XSS. So we take data from the location href, which is the URL in the browser bar. and we concatenate it with some text and put it into the body of the page, right? So if a hacker put the script tag in the URL, you're going to have a trouble. So let's see. And by the way, this is the screenshot from ChatGPT. And for all of the slides here, I'm going to use latest ChatGPT. Slides was created like 2 weeks in advance of the conference. So all the prompts and all the responses are pretty much the same today. And I'm going to have some links also for the prompts, like for ChatGPT. The answer from LLM is very good in this case. Like you see, it transformed what it was before the string concatenation. It was transformed to creation of new H1 tag, and it set text content to the href. So it's a good fix. No vulnerability here is possible anymore. But you know, for the sake of research, we want to try more than one sample, right? And that's exactly the same prompt as on the previous slide, but this time we actually have reflected one-click XSS, which is less common, but still very common type of issue. So we create a tag and we put href to the window location search, and see how we parse the location search in this case. Like we just remove the question mark after the URL and put it directly to href. And like you can recognize here is, again, the typical problem. You can put JavaScript :alert1 and your code gonna be one-click vulnerable to reflected XSS again. Let's see how LLM fixes it. And yeah, like here is like many problems. It's a little bit a lot of code, so I'll highlight for you things we are focusing on. Basically, first problem I see is the LLM uses the search params parser to get the something called URL. It wasn't like this before. Remember, like it was the just splitting the question mark. So something suspicious going on here, and the variable called safe URL, like how they actually validate URL, how LLM actually validate URL in this case. It just creates a new URL constructor. So basically, it doesn't prevent it from any XSS injection or anything like that. And for the sake of like to being 100% sure it is still vulnerable, I just copy-pasted the code from LLM directly to the example.com and exploited it in 1 second. So it is vulnerable. And quick recap, like what happened actually. First of all, LLM ruined the application logic here, because the website, like your code was rely on the fact that what goes after the question mark actually will be the back URL. It will be the part of the href. But LLM decided the URL parameter looks better than just question mark. And so now we have broken application, because probably backend renders a different way, probably other parts of the application render it in a different way. And the second problem, obviously, it doesn't fix the vulnerability. Like as we've seen, the injection is still possible, so fail. Let's try to figure out like what happened. It was exactly the same prompt, right? Like it's exactly the same scenario. What's wrong? Why one time LLM was successful and the second time not? And I don't know answer, right? Because it's LLM, it's a kind of black box for now. And but you can see a really nice example is basically you have two prompts. One prompt, like they are identical. For the developer, they are identical. I need Node.js static file server. Use pure Node.js, no additional NPM packages. And the second prompt is exactly the same. The difference is only the uppercase N and a dot between JS and the Node, right? Like if you send this text to your developer, they will produce exactly the same results. Yeah, thanks. So, and let's have a quick look how ChatGPT performs for this prompt. the first example, and like I removed half of the code, so it's not the complete code sample. You can go by the URL and check it out if you're curious. But general idea, like how many Node.js developers here? Any? Yeah, okay, some of you, thanks. So this sample is like you create a HTTP server, and in the callback, you just work with something called request.url, and it's basically what happens after the slash of your domain, right, in the URL. And obviously, this is direct user input. It is vulnerable for, like, I mean, it can introduce the directory traversal vulnerability. But in this case, LLM did really good job. It's path normalized, which will move the // segments to the beginning of the URL or remove them, and then replace pattern to cut the // segments at the beginning of the URL. So sanitization happened here. I wouldn't do it this way. I actually, if I would implement this code, I would do it differently, but it's a good solution. It works. It's not vulnerable. But for exactly the same prompt with the uppercase letter and a dot, we suddenly have no validation at all. Like, why? Why? It's same, for me, it's the same text. I need to say about also like different models may behave differently, right? Because you have a tokenizer in before the model, you have different model architectures, which may normalize kind of meaning of the prompt and make it better. But at least like ChatGPT, which is one of, I guess, the most popular of today, is making this mistake.
Thanks. Short story, we started to do the automatic remediation before ChatGPT came to life, and suddenly in November or December 2022 came to life. We were scared. I mean, do we have even a startup? And I was going to Black Hat in EU, and I told the team, hey, stop whatever you do. The entire team, all 3 people, stop whatever you do. Go and research it so we will see if we have a startup or should we close, or is there a technology to use? Luckily, it's not. Doesn't work. So we did the research. We started it with GPT-3. We did the research. Started with GPT-3, then 3.5, then 4 also, and validated. Basically, we wanted to see how good is OpenAI in fixing code vulnerabilities. We gave it an easy task. We chose two known applications, WebGoat and Juice Shop, right? We assumed actually that it was trained on them, but whatever. We scanned those with 2 SaaS providers, and we started to ask OpenAI to fix them. We gave it a decent prompt, better than what most developers would probably do, focus it on it, and still, the results were extremely underwhelming. The research is also published on our site, but the idea is that 29% of the fixes, and there were 104, I think, something like that. Yeah, 29% of them were good fixes. Not necessarily following best practices, but the fixes, like Kirill just showed, the fixes do the work. The problem, by the way, is if you fix something not best practice, you will run the SaaS scan again. It will probably report it again because it won't know that it was fixed. Limitation in SaaS. But let's give it that. Then 19%, it didn't ruin the application, which is good. It actually touched the code in the right place, which is good. Sometimes it even introduced new vulnerabilities, though. It didn't fix. So you would say, hey, why is that not the worst? Wait. The worst was that 52% were just bad. GPT changed code in unrelated areas. It did stuff like validate domain, create a new method, validate domain. You look down, there is a template of validate domain. Take an input and comment inside, do the sanitization here. So it didn't give you any help. Now, it's not just that, right? GPT, well, AI in general has some more problems with it, some more challenges that you need to address. One is the context window, the information that you give AI in order to fix something is usually small. It's always expensive. If it's not small, yes, I know there are some that can take millions and billions of tokens. It's going to be extremely expensive, and we can't build a solution based on that. The other one is, let me put it here, it's easier. Can you still hear me? Okay. The other one is parsing the LLM output, right? You want to do something automatic with it, not a developer goes to a chat and fixes things. As I said, we were looking and doing things at scale. So parsing it Didn't work as expected. You tell the LLM, hey, generate JSON, generate something else. And then large files. The more information you give GPT or others, the more chances it will hallucinate. It will try to help you so much in areas that you didn't even ask for, and it's a mess that you need to clean later. So I'll do a quick stop just because you seem tired, and we just started. Maybe we're boring, but I wanted to make sure that you understand that we are not it's not our interpretation. We actually tested it, and I'll show. I like this slide because I'm making fun of us and others. So, for example, we asked GPT to fix, not GPT. This one was, I think, it's not today, right? It's Mixtral, I think. Fix SQL injection here. Look at the code. There is no code change here. There is just a comment. Or in this one, we ask it to fix something. We asked it to fix hard-coded domain. The code change is good. It replaces it from HTTP to HTTPS. Great. Nothing to do with the problem. So you may say, okay, Eitan and Kirill, you seem like fun guys, but you're not smart enough. You didn't build a good solution. There are really good, excellent companies out there that build something with AI to remediate. Let's shame them now without putting any logo because we like them, actually. So this is one. Now, when you think about this one, does that look like they fix hard-coded secret? It's not. Now, I'm not ditching them. It's really hard to do those things, and asking the AI to do it, it's even worse. This one, for example, fix SQL injection. Oh, you just deleted the vulnerable line. Great, problem's gone, right? If you have vulnerable code, delete it, no problem. Then one of our favorite tools, I couldn't mask this one because everyone would recognize it anyway, but the idea is, and they are one of the best ones that we saw. GitHub did a fix here. Why, oh why, did they decide to delete this line? No idea. And we move on. One of the things that when we started early on, we knew you cannot fix everything. You cannot fix things that require architectural changes. For example, fixing a weak cipher encryption is very easy. Let's replace it with a strong cipher encryption. You just broke your application because you fixed it in one place, in one component. You have 10 other components that are still using the old encryption key string, algorithm, so you broke your application. So it's not just us. Those are only the tools that we got our hands on. There are other tools out there. I invite you to try. Maybe they figure it out. We haven't so far. So let's review the goals that we had. Were we able to minimize the MTTR? Yes, but only if the person that used the tool knows actually how to write it in the first place, so not so much. Can we fix the scale? Definitely no. Every fix needs to be vetted and verified, and so on and so on. So let's move to the next step. How to maybe use Gen AI when we have a fix. So first thing, let's do custom prompt for every vulnerability and often for different code patterns, because the same vulnerability, the same issue type, the same XSS, different code patterns will require different fixes. Second thing, carefully pick the context. You only wanted to give it the minimum that it needs in order to fix, because as I said, the more you give, the more problematic, the more chances that it will make mistakes. So remove everything that you can. And well, everyone that talks about AI needs to mention RAG, retrieval augmented generation. Basically, the more context that we give, the more information that we tell the AI, this is how I would do it if I was you, Mr. AI, so try to do it this way. The more you give, the better, the more consistent the results will be. And last, when it generates when the AI generated the code, we wanted to make sure that it's still compilable, because we know it makes mistakes in the generation itself. Let's look at what Kirill just showed earlier, right? The same, just different background, same everything else. This, the AI failed earlier to fix it. Now we told it fix it, but you know what? We told the AI how to fix it. Maybe I'll say her. We told her how to fix it. So we told AI, hey, please fix it by validating the URL, right? So we look at the results, and great success. We finally cracked the code. We figured out how to use AI for automatic remediation. So what we need for that? Custom prompts. The downside, for every code pattern, you need to understand it, and you need to write different different prompt. Not only that, you need to understand the code that you see now is a different pattern. It's a new pattern, and you need a new custom prompt for it. So let's think about that. The second thing we mentioned is the context, right? I don't want to give the AI all the file, the entire file, because then it will make mistakes. So can we ask the LM to fix specific method instead of the entire file? Yes, we can. But the taint flow, for those who understand static analysis, how it works, and I won't go into that because we don't have that much time, but it goes from source to sink, from the place where user input came into your application until it reaches its final destination, and it may go through multiple methods in a large file, so you can't do that, and sometimes it's more than one file. So I can't give just one method to the AI and tell her, hey, fix it. Second, the source of the vulnerability can be even static variable in the class. So you won't even see that as part of the method that you want to send. The fix may require adding some imports. If I give it only a method, where will it put the imports? I want to take that and automate it into my product. So when we were looking at custom prompts, did we meet the goals that we set at the beginning? Did we minimize the MTTR? Mostly, yes. We got to a place that most of the fixes were accurate. It didn't require a lot of check, but it still need to check every single fix. Again, you may tell, Eitan, you don't look that smart. Maybe you don't understand how to use this AI. So we went to the company that everyone loves, GitHub. And GitHub, in their article, they said and they were referring to their new code automated remediation tool, can generate fixes for more than 90% of the vulnerability types, which is awesome. Think about it, it's awesome. 90% of the vulnerabilities that you have, the different types, they can provide a fix. Not only that, over 2/3 of those fixes can be merged with little to no edits. Sounds good, right? Anyone doesn't think it sounds good? Sounds good. Some say they don't. And the reason is because the way I read it, and I'm a hater maybe, 1/3 of the fixes, you have nothing to do with them. And the other 2/3, you need to check them one by one. So did we solve the fix at scale? No. Did you help developers? Yes. You helped them. You gave them an answer. They can check it. 2/3 of the time, you save them a lot of time. But it's not at scale. So we talked a lot. And again, I'm trying to be loud and noisy, but some of you are slowing down slowly in their chairs. So let's do a small activity. I'm showing you a code here. Anyone knows where this code came from? I will give a mob hat to someone. No one. So that came from WebGoat. Now this code has vulnerability. I'll make it bigger so you can see. Basically taking account name as an input, concatenating to a SQL query, and just executing it. Obvious SQL injection, right? Simple. So what we did, and this is, by the way, not from 2 weeks ago. I created this one a while ago, but sorry. I asked ChatGPT, hey, can you fix the SQL injection in this code? And ChatGPT did amazing work. It told me, hey, this code is actually vulnerable to SQL injection due to the fact that the account name is concatenated. What you need to do is do a prepared statement with the account name. Great. And that's what they did. Now, the problem is that this fix will also break your application. Anyone has any idea? I'll make the problematic parts, I'll make them bigger again. Do you see any problem here? What? No, logging count is actually the good part. The account name is the problem. Account name is being assigned to user ID. If you look at the template as a schema, user ID is actually an integer. How could the AI know that? It doesn't have access to the schema. So actually the AI should have known that because account name is not surrounded by single quotes. So it cannot be a string. If it was a string, you would see here a single quote and you would see here another single quote. But every developer, not every, most developers will look at this code fix and they would say, oh my God, it saved me time, commit. If they have regression testing, great, it will break. If they don't have regression testing, production would break. So this is a problem. Now, I'll pass it to Chris again.
Yeah, this is kind of a little bit off topic for the presentation, but I really wanted to share for you this little bit of knowledge. We also mentioned the problem that your that it's really hard to parse output of LLM. You actually ask LLM sometimes, oh, give me JSON. And you may see like, okay, it's a perfect JSON, but suddenly at some point, if you run it at production, you will see in logs like fail to parse, invalid character. Why? Because LLM not always obey what you say it to do. So sometimes you ask it for JSON and it's not JSON. Sometimes it also changes the unrelated parts of the code. So here on this slide, you can see this is the same code sample from one of the first slides, but here, like the first line is tabs, like the tab character, and the second line is basically spaces. You know, developers do that. I don't know why, but sometimes it happens. And when we are opening a pull requests, we don't want actually developers to see changes unrelated to their vulnerabilities. So our goal is to change as minimal code as possible because it gives trust of the developer. They can read it and understand why we changed it. So we don't want LLM to touch anything in the formatting. And the trick here is like how we figure out how to parse the LLM responses without asking it for JSON or other formats. We just basically add pipes to each code line at the beginning, the pipe symbol at the beginning of line, and we ask like this tiny simple addition to the prompt. Keep the pipe symbol at the beginning of each code line. And the results are really good. It never mess up with the formatting anymore. And also, it's super easy to parse it in Python. So if you use Python, you just basically need 4 lines. You split it by the new line, check if the first symbol is a pipe, so it's a code line. And yeah, again, it helps to preserve original code formatting. It helps to ignore additional text from LLM, because LLM would often say like, oh, here is the fixed code for you, triple backtick, JavaScript, new line, then the piece of code. And sometimes you don't have a JavaScript, you don't have backticks, or like, you know, it can be whatever. And avoid JSON, because JSON was a huge pain for us in parsing the LLM responses. So I hope, yeah, this is useful, will be useful for you. And like we already talked about 2 approaches today. One is basic template, which not works. Second one is like custom prompts and more sophisticated ways to query the LLM to give the more and more precise context. But let's talk about something else. Like, what if we don't want to use AI at all? And it is actually implemented in many places today. So it's slow to implement, but you can see some of the famous companies here like Mob, ESLint. I'm mentioning ESLint here on purpose because it's a code quality tool, and all JavaScript developers are familiar with that. But it has amazing feature of --fix. And --fix is basically, if ESLint see the smelly pattern, the bad pattern in the code, it just replaces it to the good pattern. That's what we want for security issues. I also want to mention here Open Rewrite tool, which is the Java refactoring tool. You can write your own kind of rule how to change the code, and it will walk through all your files and change the code for you. And SemGrep, of course, they have automatic remediation. Like, you can, when you create a rule for SemGrep, you actually can say, this is the way how I fix it. And what common for all of these amazing tools? They all work in the same way. They basically parse the code to what called abstract syntax trees. We're going to talk about it in a minute, but all of you who is familiar with the code analysis, you probably already looked at what is IST. And second thing you need to do is to understand what is your vulnerability and where is it located, like parse the vulnerability report. And you're going to need it anyway for any of those approaches, right? Like, because you have reporting from the famous SAST provider, and you want to fix their signals, so you need to parse their reports. Then it's kind of easy. You match the original code in form of IST to the report. You figure out what's the code pattern, what actually you need to fix, right? Like what replaced what. And you need to apply the changes in some form to deliver it to the developers. I mean, you need to open a pull request, create, whoa. Okay, 10 minutes, I see. So yeah, you need to deliver it somehow to developers. First, let's quick look at what abstract syntax trees is about. Like our ultimate goal is to replace vulnerable line of code. It's from first slide, I guess, to non-vulnerable line of code. In this case, we want to apply DOM purify as a sanitizer. It's a typical library in JavaScript to remove the dangerous tags from the input. And yeah, I know this is super cumbersome, but like this is how abstract syntax tree looks like. It's basically you have a lot of nodes connected, some edges. It's a tree. It's why it's abstract syntax tree. Basically each node represents part of the code in the code, and each edge represents the relation between nodes. And here you can see the entire string is the expression statement in terms of, I think it's three-seater parser. Assignment expression is basically something equals to something. And on the left part, you have object dot property. And like basically what you want to find is inner HTML, which is reported by the SAST provider. SAST providers say this inner HTML introduces the vulnerability to your code. And you want to basically just take the right part and wrap it to the DOM purify. So you just create another abstract syntax tree node, which is call expression, and identifier is DOM purify function, and the arguments is whatever was before you started to work with the code. So kind of easy. You also need to parse the vulnerability report. Sometimes it's straightforward. I really appreciate SAST providers who use the Sarif format, which is de facto standard today. It's a static analysis results interchange format. And I don't appreciate the SAST providers who are trying to introduce their custom formats. And like it's not only about parsing XML, custom JSONs, protobufs. No, it's also about like the data is missing sometimes. You don't have like code position or line position or file information. I'm speeding up. Yeah. You also need, from the report, you need to figure out source and sink, like what Eitan already kind of mentioned. And eventually, where is the best place to apply the fix? And voila, you have the code changes, and you just render it as a git diff and send it to your developer. And yeah, let's do some conclusions here, the reviews. Basically, it helps indeed minimize MTTR because it gives solid advice. It helps to fix at scale because it works similar to ESLint, which as I mentioned before. But it's for us, for the platform which is doing fix, it's very hard to maintain the data, like the code fixers for each code pattern. And it requires a strong security team, which we have to produce the good fixes, really good fixes, which not break the code, which like satisfy the standards today. And it's really hard to scale, unfortunately, as you migrate from your check marks to Sneak and you want to add new SAST provider suddenly, or you migrate from your JavaScript to your Go, I don't know, and suddenly all the work should be done again. This is the final. So it was the like ladder of 3 different stages, and this is the last stage we have today. It's how we actually believe correct way to use AI today. We call it hybrid AI because it's a mix of 2 approaches, the pure algorithmic and the second one, which is the custom prompting. And I'm going to show it on a null dereference vulnerability, which is reported by Fortify scanner, and it may be the reason, like some people say it's the reason for a CrowdStrike incident. I don't know if it's true or not, but let's see. Like you can see, that's get environment variable. It can get, it's C# by the way, not C++, but the idea is the same. Get environment variable can return a null if the CMD variable is not defined. So the second line will break the code because CMD can be null. And the obvious automatic fix to do is wrap the vulnerable line to if statement. Just check the CMD if it's not null. And it's good, but it's good and easy for easy cases. Some cases are not that easy. You can see here the vulnerable line is settings, and settings is actually dictionary, and inside the dictionary you have the object, and object field contains array, and it's another dictionary. So try to figure out what if condition for this line needed. And instead of writing the algorithmically how to like consider all those cases and create the code which will produce the fix, the if condition, I'm talking only about the if condition here, we can ask LLM, and actually for such simple tasks, because LLM don't need any context, don't need anything, like you're basically give it very solid statement what you want to do, and it produces amazing responses. Although sometimes LLM introduces additional components you don't expect, like else statement in this case, it wasn't in the original code. But you don't care because you actually can do the same procedure as you do for the source code. You can put it to your IST parser and just extract the if condition data and incorporate this to the customer code eventually. Yeah, I guess it's yours.
Okay, so I'll try to go fast. I probably have 2 minutes, and if not, whatever. Were we able to reduce the mean time to remediate? Yes, we were. You don't trust us, you can try it. But you can build a solution like this on your own. That's why we showed also how to parse the JSON and all that. Yeah, we were able to reduce the mean time to remediate, and the fixes are following the same pattern all the time. Yes, it's 2 minutes, everyone. But the problem that we had before, it was really, really slow to add rules. It's still not fast. It's not that, hey, Kirill, fix this. It's more, hey, Kirill, let's build a rule to fix this. It takes a day, 2 days, sometimes now, but it's faster to developer, the fix. And this is where we wanted to reach. So from our perspective, this is a well done. This is the time that you can clap if you want, but we didn't finish yet, so let's wait with that. Summary, okay? So let's remember, what is AI in general? AI is a glorious copy-paste. Right? That's all it does. It has a huge place to copy from. It copies and it pastes it in a nicer place. So as Louis Lastras says, and I'm probably butchering his name, thinks of a model as an overeager junior employee that blurts out an answer before checking the facts. It knows where to copy it. It's not sure that it is the right answer that you want, but hey, I gave you an answer. So great. So what do you need to do? It is a great tool, but it requires supervision, and it's not predictable. It's non-deterministic. You can't just automate the hell out of it. It helps save developers time, even with a very basic approach, it helps, but you can never trust Gen AI. I know that in security we like to say trust but verify. I think that in AI in security you need to say verify and then trust and then verify maybe, but you can't just run. Any questions? Yes?
So in this model with these new tools that are generating solutions, I keep thinking about false positives on just the static analysis detection. That if you know, I mean, clearly you want that to be low, but there's going to be some percentage of false positives and false in your detection. And then if you're trying to correct these things, what happens when you falsely detect something and then tries to correct that?
So I'll repeat the questions quickly. Everyone knows that SaaS is notorious to having a lot of false positives. I got a stop sign, but I'll still go. Notorious. for false positives. What is a false positive? Usually it means that the code is bad but not vulnerable in most cases. Sometimes there is no problem. In your solution, what is not broken, you shouldn't. Good code, you can't fix a good code. But if the code is bad, you should fix it anyway, even if it's not vulnerable. And the reason is, because if you have Copilot in your organization, it learns from your pattern, it will take the bad pattern and now put it in another place, because as we said, it's a glorious copy-paste. Fix the false positives.
Yeah,
Not only Copilot, developers love copy-paste, so. Fix it. I mean, the alternative is doing the manual triaging, persuading someone that it's a false positive. You're wasting a lot of time. Just fix it. Get down with it, if you can. We will be outside if there are more questions, because I'm getting the nasty eye here, and we need to leave the room.
this will get hard to forget. I'm just trying to give you something.
Awesome. All right, I guess let's do this. Good afternoon, everyone. Welcome to B-Sides Las Vegas Common Ground. This talk is How I Accidentally Became a Hardware Hacker by Caleb Davis. A few announcements before we begin. We'd like to thank our sponsors, especially our diamond sponsors, LastPass and Palo Alto Networks, and our gold sponsors, Amazon, PlexTrack, and Google. It's their support along with our other sponsors, donors, and volunteers that make this event possible. Yeah, this is being recorded. Be respectful, please. It's being streamed online. When you have a question toward the end, I'll come around with a microphone, and please speak clearly into it. And yeah, let's have a good time. Here you go. Here's Caleb.
Thanks. All right. How are y'all doing today? Awesome. Well, I'm just going to run you through hopefully a lighthearted overview of how I stumbled my way through engineering into hardware hacking and maybe learn a thing or two on the way, mostly what not to do. So yeah, we'll dive right into it, and I got some time for questions at the end. So you'll notice the tense here. Things changed just a little bit instead of that should actually have a strike through, but it's how I became a hardware hacker. I think it's important for me to note that the guy that's in the other part of the heart in this photo is crucial to this story. He and I were both electrical engineering students, worked at a restaurant together, worked at multiple different jobs, and now we're back together again. So this is actually a funny picture when we were double E's and we took a staged photo. If you can tell, he's soldering with an oscilloscope, and we're not psychology students or faculty. So that's a fun little kickstart into our careers. So like I said, I'm just going to run through who I am and then talk about it. Just a few examples of times that I have learned a lesson by mostly screwing up, and what that taught me about hardware hacking and how I think it applies. Towards the end of this, I'll talk about why everybody should be doing hardware hacking. And the point of this talk is not to go too far into the weeds on hardware hacking. Find me any other time, and I'm happy to nerd out about whatever you want to. All right, so a little bit about me. My name is Caleb Davis. I'm co-founder of Solasec Cybersecurity Consulting. I was an electrical engineer. I guess I still kind of am at the University of Texas at Tyler. Did a ton of embedded development before that. A lot of ARM core microcontrollers, FreeRTOS for HVAC, so heating, ventilation, air conditioning. We always used to say we would close our eyes and pretend it was lasers because it was not that exciting. But we did learn a lot along the way, as you'll see. All right, so one of the first things that I wanted to talk about, hopefully you can see here, this is probably the biggest nudge into hardware hacking for me, was really just being a terrible electrical engineer and bad at circuit design and all of the things encompassing with that. I think I've gotten a little bit better, hopefully, but one of the things that we often see when we're putting a board together is that we'll have to modify that board or do some sort of rework, right? So I've got a few examples up above that I'll talk about, but the things that we see commonly are the wrong component footprints, right? If you lay out a part or if you have to design your own part, could be a huge problem. If you get the dimensions off by even the slightest millimeter, you could be talking about a short in a system. Incorrect schematic wiring. I mean, if you're having to route multiple schematics and you are reading tons of data sheets, right, it could be very easy to cross those wires. And when you cross wires on a schematic, it's not a big deal. When you turn it on, you see that factory installed smoke that I'm sure multiple people in here are familiar with. Wrong component orientation. This is another big one that we've seen where screw up, try to send the board or the component to the back side of the board instead of the front side, get all confused, and then now we've got to literally flip transistors over and then solder them upside down. So we have actually done that too recently, I would say. And then the last thing, accidental shorts. I've done this recently as well, just throwing a via down on top of traces when you shouldn't, and what that means to your life and how sad it's going to be to fix that problem. So some of the learning opportunities, I kind of alluded to it already, but when you have these issues that come across, you can run a new board and wait that process, and it could be weeks depending on your lead time for boards. But something that I think is kind of inherent to what we do as engineers and tinkerers is that we try to fix it, we try to root cause it, and then that will inform our next design. My argument here is that a lot of those tools that we just did and took for granted kind of propelled me into hardware hacking, because I think that the first thing you do when you start looking at hardware board, you need something?
I do actually.
Go
I
ahead.
believe you made a outrageous speaker request when you signed up for this
Oh,
talk.
good Lord.
And I believe that you asked for the same rider that Nicki Minaj has.
I did.
Yes. Okay. So I have your 24-pack of Dasani. The other half is on ice in an unspecified location.
Great, thank you.
But there's the on ice part. I've got your dried cranberries. I got your almonds here, and I'm gonna go out and get your throat drops and your fried chicken.
Thank you.
But give me a
I think
sec.
she said she has Nobu too delivered, so just let me know where to pick that up.
Okay, right.
That's
yeah.
awesome, man. Thank you.
The last person who had Nobu ended up not being able to speak in this track because she got food poisoning. So I'd
Oh,
be
okay,
careful
great.
with
All
that.
right, thanks for
Anyway,
that's awesome. Thank you. All right, I'll fill in the gaps here because I know y'all are probably trying to figure out what's going on. In the CFP, there was a spot for like special requests for the speakers, and I'm pretty easygoing. I don't have any special requests. So I asked for Nicki Minaj's ridiculous set of
Sorry,
green room
what's
requests,
going on?
and they
wait,
obliged.
What's going on?
For some reason?
Excuse me. Yeah,
Yeah.
I am really sorry, but we just received a cease and desist letter from Nicki Minaj's
Oh.
attorney.
Oh yeah.
It turns out someone was put out.
Oh,
and it was
okay.
Nicki
That's
Minaj,
fine.
it seems.
I didn't realize she could patent such a thing.
Well, yeah, it's funny. I didn't think you could copyright it either.
Yeah.
Hey, I'm Lydia. I'm our chief legal officer. Yeah,
Oh,
we
okay.
have one. But yeah, it's come to my attention that you've made unauthorized use of my client's copyrighted work entitled Performance and Security Contract Addendum for Anika Tanya Mirage, aka Nicki Minaj, in preparation of an outrageous speaker request for your 2024 conference.
Yep.
We've reserved all rights in performance and security contract addendum for Anika Tanya Mirage, blah, 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 blah. It's too much. First published to the world in February 4th, 2012. So give me a second to keep reading this. Demand that you immediately cease and desist the operation and delivery of the outrageous speaker request. But, okay. Well, wait a second. So I think her rider says, among the other things, you are bringing the fried chicken, right? All right, cool. But it said 24? And we've got half on ice and half here? All right, cool. We don't have 24 anymore, so all right, okay. We've desisted. Enjoy the
We are
letter.
desisted?
We have desisted.
Okay, great.
Have
Thank
a great
you.
talk.
Thank you so much. Y'all are awesome. That's so funny. All right. Well, another example of, sometimes decisions that you make can have real impacts on how things work out. But yeah, that's hilarious. I can't believe that they actually obliged, and I'm really looking forward to the fried chicken that they say is there, and I very much doubt it is. All right. So getting back, the overall learning opportunities, like I said, when we drop down the wrong part, when we drop down wrong orientation, etc., we've had to depopulate too many parts to count, and a lot of times, that's going to come in handy. And I'll talk some more about the specific use cases where it does. But the ability to do some of that fine, micro soldering, like I talk about later, is crucial, right? When you're talking about attacking a microcontroller that's got, I think everyone's talked about, depopping capacitors or something like that for power analysis. If not, I'll talk about it here. But that's a huge part of it, in addition to, dead bugging parts, etc. The other thing that we've done a tremendous amount of times that I think does come in handy is just cutting traces. So, if anyone's not familiar, when you lay out a circuit board, you'll have, various layers, and those layers will contain copper traces from one to another. It's effectively just like wiring on a breadboard. A lot of times when you do run into those issues with like schematic wiring, we will have to get under a microscope, cut a trace, and we'll have to sometimes even solder from that trace, which is what you can see in that picture on the left, solder from one trace to another. This is crucial, and you'll see in a second why having the flexibility to do something like that on a board that may not give you the ability to connect. So just quickly talking through some of the things that we have done. I'll just go through the bullets here, and then I'll talk about some of these pictures. But sometimes signals are inaccessible, right? A big part of hardware hacking is leveraging signals, and analyzing it, decoding it, even manipulating it. So when those signals are not accessible via some sort of header that you can connect to or some other means, a lot of times you'll have to hack your way into that signal, right? Whether that's scraping a trace and soldering onto it, depopulating a component, or any of those things are kind of in play for hacking those PCB inter bus communication type signals. PCB man in the middle, it's the exact same thing. To man in the middle on a PCB, you have to go through tremendous lengths a lot of the time. Dead bugging, if anyone's not familiar, it's when you're taking a part off of a board and then soldering directly to that part. So a lot of times you'll have like this AT mega part will have like a ball grid array under the bottom, and it's very fine in between, and then it takes a ton of very meticulous and precise soldering to actually attach to those signals, and then exfiltrate the data from the board, modify it, redeploy it. The world is your oyster from there. Another thing that I would love to talk about, and one of the things I can nerd out for a while on, is side channel analysis. I kind of alluded to it. One of the biggest things for like power analysis, for example, voltage rails, if you're familiar, will often have a ton of capacitors. Capacitors store electricity, right? So to effectively measure things like power or inject a fault, you'll often have to modify the board first before doing those types of attacks. And it just makes it, a little more responsive to what you're doing. So depopulating components is crucial if you're even going to start doing side channel analysis. And just talking about the pictures. So the top left is just an example of a BGA component. You can see kind of the traces moving out to those vias. Those holes are called vias. That's a perfect example of if there's a signal that's coming from there that I care about, it may not be exposed on the board if it's not like a QFP, which is a specific type of package. So I might have to actually, scrape that trace down and solder to that trace, or drop a probe, or solder 30 gauge wire or something like that directly to that trace. So, all those steps that we learned for fixing the things can also be applied to this is the point. And then in the middle, it might be hard to see, especially for those in the back. We've had to do this several times where, you think that you cut the right trace and then you realize you did not cut the right trace and everything ceases to work. And then you have to literally repair a trace. So you cut up some 30 gauge wire, you drop it back down, and you solder it back together. That's crucial too in hardware hacking, right? You hack the wrong thing, and hardware denial of service is not really super exciting. So you fix it a lot of the time. And then the picture on the right, I actually did this at one point. This was for a clock glitching, I believe, or fault injection of some kind. But that's actually a surface mount resistor that someone had this was not my picture. Someone had the ability to pull that up and then place it on one side, and then that opens up the ability to connect to both sides of that resistor, which is really, it's more difficult than it might seem. All right, so some other examples that we learned. I mentioned that me and the buddy that I referenced started in college, which is where we made a lot of these mistakes early on. Really, a lot of that stemmed from no money, no problems. We were broke college kids, and we were trying to be electrical engineers, which turns out is fairly expensive. So a lot of what we had to do there was, try to be resourceful. So some of these boards, like the board on the left, we thought we were really smart and sourced a ton of components from Mauser, and then, we were like, these capacitors are orders of magnitude cheaper than these, I'm going to use these, and then realized that they were 0402s, and we couldn't pay for pick and place, and we had to solder them all by hand. So that's, just to give you an example, 0402 is the part in the middle, and that's a matchstick. So, we had to go and solder all of those by hand, whereas we could use something like, the 0805 or even bigger, and do that exact same thing. We were dumb and young and thought we were just saving a couple cents, and it turned out to cost a ton of time. But once again, the spirit of the talk is that, that gave us the ability to learn, and, we've soldered as low as 0201s with the naked eye, and I think my partner's actually soldered the 01, 005 under a microscope before. So, I'll get back to, what the point of this whole talk is, but, this example of just being, constrained with money and trying to figure things out. I mean, I think that's part of the spirit as well of a hardware hacker, because that's often your goal as well. All right. So another thing that we learned is, we often had hostile conditions that we started working in. Just quickly talking about these pictures. Like I said, we worked at residential HVAC. It was called System Extreme Environmental Testing. So this was a chamber where we put all the outdoor units. It would run and cake it with snow, feet of snow, and it would be freezing temperatures. And for some reason, we would go and have to debug something that would break in there, and we would literally have to debug in these conditions a lot of the time. And this is where, we'll talk about learning. We got the opportunity to learn with some complex tools that I'll talk about in a second. But these were the hostile conditions. I mentioned here that, when you're freezing and your hands are shivering and you are having to do all of these things at an intricate level with hardware, it really lends itself to expedient root cause analysis because you want to get out of there as quickly as possible. So just to give you, that's me in seat. That's one of my business partners up on like a big lift. It also does the opposite, where it was like 120 degrees, I think, when he was doing this picture. And then this thing is called seat, this chamber. So someone thought it would be funny to put a seat in seat. So someone took someone's office chair and threw it in the snow room. All right, so let's talk about complex tools. So the tools that we were using in those conditions, it gave us the opportunity to go and debug with these complex things, right? So like a logic analyzer, as you see on the left, really used for decoding signals. I think it's probably the most important tool to a hardware hacker. You've got a big range. You can buy cheaper logic analyzers and get by. The big thing is when you want to get into higher sample rate that you'll need, or if you want multiple channels, or if you want the ability to do analog signals relatively well, you can get up into the $1,000 range with like the SidesLV Logic 16. Another thing that we used consistently was a portable oscilloscope. So that's actually the third picture. This is just looking at all kinds of signals and waveforms throughout. We not only were we working on programmatic boards and looking at things like I2C and SPI and UART, things along those lines. We were also looking at how discrete circuitry operated. So we were doing electrical engineering things up on a forklift in the snow with the portable oscilloscopes. And the last thing, universal programmers. That's that Sager J-Link there. This is crucial. This is crucial for reading firmware from a target or writing firmware you can attach, you can debug on target, you can do a ton of things with that. So those are some of the tools that we would use just to debug in our conditions. And a lot of times we would find ourselves hooking up a SidesLV, hooking up an O-scope, wondering what kind of ridiculous ambient conditions are causing this problem. And then I can't tell you how many times we realized that we plugged in the JTAG header upside down. So this is one of those examples where, a stupid problem at being, you have something unplugged, you've got something plugged in upside down, you've got, XYZ something, but you throw all these tools at it, and, really it gave us the opportunity to learn how to run these tools, especially in these hostile conditions. All right, next lesson that we learned, one-way ticket to dependency hell. I think everyone in this room has probably seen something like this at some point, and hopefully it's not too triggering for anybody. But yeah, whether it's writing embedded C code or if it's writing some Python requirements or whatever it is, we'll often run into dependency hell just as general software developers of some kind. So that's the same for hardware, for firmware. What the point here is that dealing with dependency hell and not shunning it away is actually something that's incredibly beneficial as well, given that it teaches you more about your specific problem, teaches you more about in my case how the compilers actually work, the way that I'm linking libraries, and understanding at a fundamental level how the code I'm creating gets translated to machine code in my case. And that, to me, that's crucial to a hardware hacker as well, because you're starting from that point. If I go pull firmware off of a target, you're starting from bytecode, right? So the ability to get back to something reasonable, if you have an understanding of not just the dependencies, but the intricacies of the code that's being deployed, it's crucial in moving forward there. All right, bonus slide. I did look up the statute of limitations, and they have expired in Texas, where I'm from. So I can tell you that a lot of times we had the opportunity to learn all about physical pen testing / B&E, mostly due to our general forgetfulness. If you could see that picture, that's actually the picture of the facility that we used to work at. There's a little cage on top that you might not be able to see. That cage was added because of my partner that I keep mentioning. We used to just forget, and we would have to break into the building, full disclosure. So we would have to jump over the fence. We'd have to tailgate. We'd have to, we would clone each other's badges back before it was cool. And then other physical weaknesses, like, we never really picked a lock there. We'd probably get in trouble for that. But, the air can attack is what we use consistently, massive air through the motion sensor, break into the room, which is, these are all the things that we did, allegedly. And, it's funny now looking at all those opportunities that we had no idea. And now, if you look at the list of things we legally get paid to do now, it's the exact same list. So, that's another spirit of, the point that I want to convey today is that, all of these things that are exciting and fun, and, we thought we were just kind of taking for granted as part of our job. Well, I guess breaking and entering wasn't part of the job, but the things we were taking for granted could also be applied to, a different career entirely. All right, so now I get to nerd out a little bit more. Hopefully, all the things that we talked about kind of come to a head when you go deep into the world of hardware hacking. And like I said, the point here is I'm not trying to go too deep into hardware hacking. I'm happy to do that with anybody at any point, but you can see some of the same tools just with these pictures that we're seeing here. So I'll briefly talk through some of these and figure out, or just kind of allude to what they are, how we can use electrical engineering to get to this point. So fault injection, I guess show of hands. Is anyone familiar with like fault injection, like voltage injection type stuff? All right, sweet. Well, I'm definitely going to go into a lot of detail then. So if you imagine an embedded part is going to read memory at some point in time, especially when it boots. So, a lot of these microcontrollers will have a voltage rail. That voltage rail is powering the core, right? In order for it to read memory properly, it has to have a good solid connection. It's got to be fully powered. When you get it into a state where it's not operating entirely well, like sort of kind of a brownout state, you can cause it to do faulty memory operations. So something that happens consistently and across the board is that if you can change that voltage to the core at a specific time when you're targeting specific pieces of either the bootloader or the way that the firmware operates, you can actually cause an invalid read. And sometimes what happens, especially with bootloaders like ST Micro, if you're familiar with that, they will read that and then say, okay, well, that's not the thing that I thought it was. I'm going to revert to this boot sequence, right? So just to give you an example, the default is like level 1, right, where it's kind of a little bit of permission, kind of not. If someone enables level 3, you can do this type of attack and go back to level 1, and then you open up a ton of different things that you can do to that target just by doing some basic electrical engineering where you're using a multiplexer to literally switch rails pretty quickly, right? So I think, fault injection or any side channel analysis is the perfect harmony of electrical engineering and hacking. Yep.
I don't know, I'm maybe jumping ahead of slide.
Sure.
You might want to explain why you're doing that kind of fault injection.
Yeah, sure. Yeah. So I mean, in general hardware hacking, I think the point of hardware hacking, a lot of folks will say, you have physical access, who cares at this point? And I think that's it's such a misunderstanding of the capabilities of hardware and how you can secure hardware. So, what we're after, to get to your question, is firmware. We're after sensitive information. We're after, intellectual property. All of those things that we can take that firmware and reverse engineer it and conduct a broader attack at, the infrastructure that's supporting the hardware device, or we can, exploit that IP. Gray market attacks are a huge thing with hardware, and even just, manipulate something if it's, a critical infrastructure component, right? You can manipulate it and cause it to perform errant operations, whether it's, flashing a device like a end-of-line run tester, or, some sort of safety operation. If you can compromise that, it's a major problem, right? So one other thing, I'll talk about power analysis too, because I think it's awesome. So everyone's familiar with AES, right? AES encryption. Okay, cool. So AES, I think for AES 128, if you try to brute force it, takes like a billion years or something like that. I'm sure someone will correct me afterwards. With correlated power analysis in certain conditions, certain encryption modes, you can get that to as low as 5 minutes, right? Because what you can do is you can look at the power analysis, and you can look at all the permutations of an AES key. And with some boards, there's a property where you can correlate those two data sets, and you can infer specifics about the operation, the cryptography of the system just by the power analysis, right? So, to me as an electrical engineer, reading power and, writing some code to process the data, that's trivial, right? And then if you couple that with the cryptography piece of it, we're talking about electrical engineers can break into things that they should not with relative ease. And this is, I don't want to minimize, these are microcontrollers that are everywhere. STM microcontrollers, NXP, you name it, they're in everything. And with the emergence of IoT, it's going to be more and more of a problem. And vendors are just now starting to fix it, much less, your run-of-the-mill manufacturer that's trying to get to market as quickly as possible and be as cheap as possible. So, these attacks are not just in academia. These attacks, I think, are going to be more and more pertinent as we progress, and as these things become, easier to use, which I could talk about more at a later time as well. All right, so what now? My colleague made me put this quote in there: "If hardware hacking is cool, then consider me Miles Davis." I stand by that. I don't know who Miles Davis is, but hardware hacking is cool. All right, so the topics and takeaways that I want to give here, the growth mindset, and then celebrating small wins. A lot of times we would go and we'd have to break into our employer, use all their awesome gear, and fix all the boards that we broke at school. That seemed daunting at the time. It seemed like we were screwing up. It seemed like we didn't know anything about electrical engineering. But the things that we were learning, I can see now, were completely invaluable. We learned the resilience of having a broken board and fixing it. We learned all of the specifics of how to do that, and all the skills that we can now apply to our careers. I think key to that is that growth mindset, and making sure that you keep track of, even when it's terrible and you feel like you're not learning anything, you're banging your head against the wall, it's always progress, right? So making sure that everyone, as much as I can, everyone has that same mindset moving forward, that it's for a greater purpose at some point. The other thing is that I went, I think, 5 years as a double E, not realizing the world of embedded hardware hacking. And I tell people now that if anyone would have told me what you could do as an electrical engineer in the world of cybersecurity and hardware hacking, I would have never done anything else. And I really mean that. I think the side channel stuff alone is so awesome and fascinating. And there's a lot of really smart people that know how to do it, but it's a relatively untapped space, I would say. So taking it and making it more approachable to good people, hopefully, that are making the world more secure. I would say why do anything else? Yeah. And then the last thing, I think this is clear: don't be afraid to fail. Right? Failure is where we learn all of our mistakes. Hopefully I was a little bit vulnerable with all the dumb mistakes that I've made over the past 10 years or so. And, realize now what that led to. Now, I get to hardware hack all the time. And, without all the failures, without all the challenges that I faced in my career, that wouldn't have been possible. So that's the biggest takeaway there. And I think that's it. So any questions from anybody? All right.
In what circumstance you did physical pen testing if you are into hardware hacking?
Physical pen, like breaking into a building?
Yeah.
Yeah. The best example, we had a building in downtown LA, and we just had to go and we impersonated, wore the nice 3-piece suit, and walked into the building and realized that they did have like security guards, and got scared, walked out, came back around, and then we just literally tailgated went up to the floor. I was sitting next to the CFO, and just plugged into their network and sat there for about 45 minutes until we got bored, and then just left. I mean, it's one of those things that, especially me I don't know if y'all know, I'm from the South, from Texas. Just general talking to people is pretty easy, and people are too trusting, I would say. So I had a pleasant conversation with a lady that almost gave me just the Wi-Fi password just by me asking. So, that's kind of what you're up against a lot of the time, is that, I'd rather me do it than somebody else. But, if someone goes to those means of, just getting access to your network, it's pretty easy a lot of the time without all the crazy, lock picking, air can type stuff. Any other questions? Yep.
What do you think the risk is of people not understanding their hardware? I mean, they've got great software, they got great programs, but they don't understand what's actually sitting on the board of their backbone or switches, routers, and stuff, or actual physical components. Yeah,
great question. So I don't think people understand the downstream impact of how the hardware can interact with the broader ecosystem. So the best example that I have with that is not like, networking gear. It kind of makes sense. You understand that it's kind of the backbone of an enterprise. But I had one where, it was something innocuous, where it was a water filtration system. And that water filtration system had API keys that were stored on target. And I pulled it out of like non-volatile memory on target through a UART interface. And then I took those keys and then I attacked the API. And then I attacked the API. API had indirect object referencing. And then I went from a physical device that probably would get thrown away to I take down your entire API for all of your customers, right? So understanding downstream effects and how easy it is to actually reverse engineer something intelligible about a system, I think is the biggest thing that people just miss, because they see it, like I said, they see it as, you have hardware attack, you could just pull the power plug, denial of service, game over. That's not the case. There's a lot more that could be done.
What's the most questionable thing you see when you're
Oh gosh.
hardware where you're like, you don't understand why it's there? Like, it's not
Oh man.
But like, what's the questionable thing where you're like, it sticks out? Like,
I mean, we've seen UART, like UART is universal asynchronous receiving and transmitting, just like a serial interface. But we've seen root on UART on advanced devices that have no business exposing root level access to someone with just general physical access. So that's probably the most egregious. I mean, we've seen everything from, unsigned firmware that we could just, I've been able to text the device and change the upgrade server with an SMS message, and then host a malicious firmware file and bypass their signature verification to, overwrite that firmware on a embedded device and, lock it out, do some crazy stuff with the I/O. There's a lot of egregious that goes on out there.
So I wanted to actually kind of like reinforce the answer that you gave to this gentleman's question. So I too am an electronics engineer who somehow managed to get himself a role as an embedded penetration tester. And yeah, they're paying me to hack. What?
Yep.
This is so cool. So anyway, yeah, and a lot of threat matrices having physical access to something is usually considered like pretty low. Like if you go ahead and calculate your risk scores, they'll come out low. But this is the caveat. It's just like you said. It's like, so what'll happen is a real world attackers, if they want to like attack your infrastructure, whatever, at scale, what they're going to do is try to get a hold of one of your devices.
Yep.
And this could be just buying it off eBay. And they will attempt to reverse engineer it to find things like what he just talked about, like hard-coded API keys in the firmware, in clear. So if you didn't lock JTAG, then that becomes trivial to dump the firmware. If you did lock JTAG, then that's when you got to start jumping into things like fault injection and all that to get it out. But once you do, and you get it, then or you find that, okay, there's hard-coded credentials in there, and they're the same for every device, like they're not unique per device. And then, pretty much like what he just described, then it's like, okay, then things get really fun.
Yep.
So for those of us who may have come in a little bit late, would you mind sharing or going back to must-have tools or capabilities for people trying to get in?
Yeah, sure. So I think I mentioned these because I think these are probably should be top of your list. Logic Analyzer, hands down, is the best. It gives you the ability to decode signals, right? Whether that's interbus communication, or if it's something that's like an external signal, sometimes that's helpful too. If you don't want to buy like a custom transceiver for everything like RS-232, 45, whatever. So a good logic analyzer, I think, is the best. Universal Programmer is probably second on the list, where you imagine the same sort of deal with the ability to just be dynamic and deal with multiple targets. A Universal Programmer inherently does that, where thousands and thousands of microcontrollers, like this gentleman mentioned with JTAG, if that interface is enabled, you can use JTAG, you can wire it up to it, or a lot of folks will just leave a handy dandy header for you, connect to that, dump the firmware, and then you got a ton of stuff you can do from there. Last thing I'll say, probably a universal, well, I say Universal Programmer, that's more of a universal debugger, but a Universal Programmer, to the extent that you can dump like external flash, is another big thing, where if you depop something off of a board, you throw it down on something else, a lot of times that's where you'll find like the API keys, hard-coded credentials, all that kind of stuff. And those Universal Programmers are the same, where different form factor, you can exfiltrate information from memory or whatever it is. So I'd say those big three are probably the most. I'll give you a bigger list if you want to stop by later.
Hey, for someone.
No, sorry. Next.
Oh, okay.
Go ahead.
Okay. For someone wanting to dive deeper into this, what do you recommend? For example, I went to a coding boot camp. There's a lot of like online resources for learning on your own how to code without going through an EE program.
Yeah.
What do you do on the hardware side of things? Like I wouldn't know what I'm looking at if I picked up a logic analyzer or an oscilloscope today. How would I learn that on my own?
Yeah, that's a great question, because I think it's inherently difficult to learn hardware hacking, because it's very easy if you touch the wrong thing and you solder to the wrong spot, like that factory installed smoke is real. I've seen it a lot of times, right? So it is more difficult. I think that we're seeing more and more challenges like Hack the Box or Try Hack Me are trying to do some more hardware-based things, and there are kits that you can buy online. Actually, if you see me after this, I can point you to some stuff. I actually made an open source learning environment where you learn some of these things. The barrier to entry, though, is always the hardware, right? So getting your hands on something that's cheap enough to understand the premise, and then you can work your way up, nice tools whenever you earn your keep and you understand like what's going on. But I would say there's some great books out there. No Starch Press released IoT, Practical IoT Hacking, I think, and then the Hardware Hacker's Handbook. Those are two great books that I'd mention too. Yeah. Back.
Hello. I believe you mentioned SMS earlier. Were you referring to a mobile device or just like an embedded device with LTE or something?
Yeah, so a lot of these devices will be cellular for a number of reasons, right? Cellular is probably, when something's not close to an access point, or, you don't have long-term connection, cellular is often used in a variety of industries. So, the risk to cellular is is crucial, right? And I think that there are a lot of issues with, it's less so on the cellular piece. There are things that you can look at. I think they're a little more complicated. And then sometimes when you're testing cellular, you can get into trouble and like have black vans roll up to your house if you broadcast the wrong signals and like interrupt emergency response. So be careful doing that. But I think one of the biggest things with SMS is just general, improper parsing of data and trusting data that you shouldn't. And that's the issue that I ran into. It's like I use SMS as a vehicle to bypass bad signature verification of firmware, in addition to improper access control of elevated function like firmware updates. So SMS is a vehicle. You can attack that just like anything else. But yeah, it's super prevalent with hardware devices.
So this actually was a really good talk and presentation. There's a field of systems engineering called anti-tamper.
Yeah.
And if anyone here hasn't heard of it, I highly suggest you actually start researching it, because there are jobs that not only that pay you to break into systems, but pay you to develop countermeasures to exactly what you're talking about here. And a lot of that field of study came out of the fields of reliability. So to answer your question, sir, for COTS components like we're talking about here, you can get all the specs and schematics online. And that's the first place that our adversaries in certain countries go to first.
Yeah, that's a great point.
And the best way, the reason why they are surpassing us is because we let it happen. It's because everything is out there.
Yep.
And that's how you all can obtain this stuff. It's all out there. It's all free. You can get the spec sheets, the data sheets. You can pull it all. And that's where you learn. If you learn how it works, and you can learn how to dismantle it.
Yep.
Excellent talk. Thank you.
Yeah, thanks. Yeah, FCCID.io, if you're familiar, anything that has an FCC ID on it, go look it up. A lot of times you'll be able to dump the entire schematic, the testing from FCC. It's a function of exactly what he said. A lot of this is in the open domain. Some vendors are better than others, but just go Google this stuff. Don't read like an 1,000-page data sheet. Figure out how to read data sheets first. But yeah, I couldn't agree more. And then anti-tampering, I know we're almost up on time. Just to give you an example, so I mentioned correlated power analysis is what I was talking about. Some of these chips will do some crazy stuff like injecting random noise and current consumption, which breaks that correlation. So, I can't remember who asked, but in the spirit of where we're moving as an industry, we're seeing more and more of components like that strengthen the hardware at a fundamental level that we need to see more and more. The problem is, it's BOM cost, it's complexity, it's dev time. That's why we're not seeing it as much as we should.
All right, thank you. I think your fried chicken's getting cold.
Thank you all, appreciate it.
Yeah, it's just like a good time. All right, good afternoon, everyone. Welcome to B-Sides Las Vegas. This is the Raiders of the Lost Artifacts, given by Yaron. I think I got that right. Thank you for coming out. We'd like to thank our sponsors, Prisma Cloud and Vanta, as well as Adobe, DropZone, and others. It's with their support, along with our sponsors, donors, and volunteers, to make this possible. Please keep your phone silenced. This is being recorded and streamed on YouTube. If you have questions, I'll come around with the microphone. Please speak into the microphone so that the people on YouTube can hear you. And with that, let's hand it off.
Thank you. So, thank you all for coming to this talk. I'm very excited to be here. Before we begin, I would like to thank our sponsors. Just kidding. Basically, I managed to hack into these organizations, and some of them did offer us generous bug bounties. And let's see how we did it. Oh, sorry. It's on? Not yet. Cool. So this is the organization I managed to hack. It's more impressive right now, I guess. So let's see how I did it. So first of all, my name is Yaron Avital. I'm a security researcher at Palo Alto Networks. I have about 20 years of experience in the cybersecurity space. Started off as a developer, then moved to be a security researcher, where I've done vulnerability research, mobile security, bug bounties, and many other cool stuff. In the past few years, focused on CI/CD security. First at Cider, the creator of the OWASP Top 10 CI/CD security, which was acquired by Palo Alto Networks. I've been working there ever since. Last year was the year, exactly 1 year ago, I gave a talk called Actions Have Consequences, the Overlooked Security Risk in Third-Party GitHub Actions. And one of the concepts I raised over there is the permissive nature of the GitHub Actions pipeline and how very few organizations do manage their pipeline permissions. And today, we are going to see the consequences of not managing your pipeline permissions. So the agenda for today is a new novel attack path I found against public repositories on GitHub. Basically allowed to run my malicious code into your devices, even the ones in this very room. We are going to see some demos, and of course, we end our talk with mitigations and takeaways. So GitHub Action, in a nutshell, is a widely used CI/CD platform by GitHub, basically code execution as a service, enable you to build, test, and deploy your code. And because it's doing a lot of integration with your cloud provider or Slack or Jira, it needs secrets. So a lot of secrets is going on over there. And GitHub Actions allows you to upload artifacts as part of your pipeline. Now, these artifacts are not packages. They're not like the formal binaries. They're mainly designed to share data between jobs or for developers to being able to persist data in order to debug the pipeline afterwards and stuff like that. Now, this example here is an artifact from Firebase by Google. And if the repository is public, then the artifact is public as well, and you can download it. So I had this hunch of doing secret scanning on these artifacts because they are being compiled at a very sensitive environment. And I haven't heard any chatter about it, anyone that does that. So I decided to take the most popular starred repositories on GitHub and try to scan them for secrets. And it worked, and I even have a name for it. I called it Artifact, which is artifact packed with secrets. I found various secrets for various cloud providers like Last.fm, DigitalOcean, Codecov, GitHub. And I did found some personal access token, which the users use to manage their repository, push code, etc. But that is not the focus. I did found additional tokens. These belongs to GitHub, a GitHub token and Actions runtime token. And this token used by the pipeline. It's not like the previous token we saw. It's explicitly used by the pipeline to interact with the repository, and we will cover them in a minute. So the way things work in the GitHub Action, every time a workflow starts, an ephemeral short-lived token called GitHub token created. And this is how the pipeline can interact with the repository, clone the code, push code, and do stuff like that. Now, the permissions of the GitHub token is basically up to you. You can configure it inside your YAML pipeline like this. And if you don't, the default configuration from the repository will kick in. As for the Actions runtime token, it's a different type of token. You can use it to access the cache system to upload a new artifact or get new crash entry and stuff like that. Now, because secret scanning involves with a lot of false positives, I wanted to be sure these tokens are the real deal, they are legit. So I decided to dig in and try to find out how they ended up in the artifacts from the begin with. So I quickly find out the immensely popular action checkout. I think it's the #1 action on GitHub. It used to store the credentials, persist the credentials, the GitHub token inside the local Git folder by default. This is the base64 representation of the GitHub token. And on its own, it's not a problem, but combined with the fact that a lot of users simply check out their code and upload the entire directory, including the hidden Git folder, that's a problem because your token is leaked. Sorry. Moving on, another problematic pattern I've noticed is that users that use the super linter, which is popular code linter, which is supported by many languages, it used to print the entire environment variables to logs. And when it comes to the context of CI/CD, where secrets are being loaded as environment variables, probably not the best idea. And these logs were uploaded as artifacts as well. And I reported this behavior to the maintainers of the superlinter, and this behavior was fixed. So now, it's the favorite part of my work, hacking. I got a lot of tokens, different kind of tokens. Let's try to use them. But quickly, I found out there is a problem, because during the time of my research, artifacts were only available after the workflow has ended, which means the GitHub token already expired, so by the time I tried to use it and push code, I always got the same error over and over again, 401, because, again, the token is invalidated, and there's no way I could win this race condition. It was rigged, basically. So from the majority of tokens I got, I lost the majority of tokens from the tokens I got. I still got the Actions runtime token. And moving back, this is the decoded part of the JWT token. I have noticed the expiration time of this token was 6 hours, which is plenty of time to commence an attack. So this is what I did, a deep dive into the upload artifact action. I wrote code that wraps the logic of the upload artifact. I traced the victim's workflow. I remember I have 6 hours to do so, and swapped artifact with a malicious one. And let's see a cool demo of doing exactly that. So on the right, you can see I'm tracking the workflow. I've downloaded an artifact. This is, by the way, a real attack. This is a project called Schema Crawler, a real project on GitHub with many stars. And I've noticed the action random token was leaked over there inside the artifact. So I wrote a nice POC that downloads the artifact, extract the token, and use it. And I've swapped the artifact. You can see, remember, I don't have any permissions to this repository. And just like that, I replaced the artifact with a malicious one. Now, just a second. Now, what's the meaning of this attack? Basically, I could achieve an RCE in this way, remote code execution, because if you remember, I told you that artifact is used to share data between jobs. So a job that tries to download this artifact, which can be binary, of course, and execute it will get compromised. The same way, developers trying to consume the artifact and try to see what's going on in their pipeline will get hacked as well. Now, this time I was pretty happy from achieving this RCE. I managed to use the actions runtime token, but then something truly magical happened. As I was going through the GitHub changelog, this is something I do very often, I have noticed they have done a complete overhaul to the artifacts v4. And now, the artifact is available as soon as it is uploaded by the job. And I didn't have to basically wait for the workflow to end. That means I have an opening for a race condition, right? So I need to do the following. To trace workflow triggering, identify the exact moment the artifact is available, download the artifact, extract token, and create a branch. Now, why create a branch? Because I wanted to prove I have write permissions, and create branch, and obviously I didn't want to push malicious code, and create branch does require write permissions. So this is exactly what I needed to do. And I needed to do all of the above under 2.5 seconds. You see the little animations, that's exactly 2.5 seconds, because that's the time between the artifact is available and then the job dies, which means the token is invalidated. But sadly, I was nowhere near to win any race condition. I simply wasn't fast enough because downloading the artifact took a lot of time. But then I had this really cool idea of why not using GitHub Actions as an attack infrastructure, because I was able to be much closer to the target. It can be triggered remotely, which is something I needed. And it offers much lower latency and faster downloads. So I did exactly that and wrote an offensive GitHub workflow. I present the repo repair. And basically, all I needed to do is to point this guy towards a potential repo and wait for results. And this is the attack flow. I needed to monitor pipeline triggering, so I wrote a software that tracks when the pipeline is triggered. Pipeline can be triggered by a contributor contribute code or a nightly build or something like that. The pipeline uploads the artifact. I need to download the artifact, use the GitHub token, in my case, create a branch. And 6, by the time the job ended and the token invalidated, I don't care because I managed to use it. And as a bonus, because this attack was fully automated, I sent a Telegram message to myself so I know something has happened. And it worked. Soon enough, I got a lot of these messages, meaning basically that the repo repair has managed to compromise the repo. This is my favorite one, by the way, of me doing the dishes. And this is the first race I won against Project Claire by Red Hat. I've managed to create a branch called Impala. It's a very popular container scanning. It has 10K stars on GitHub. Just as easily, I could have pushed malicious code. And let's see a cool demo of the real attack against Claire. So on the bottom screen, I have the software that tracks the pipeline triggering. In this case, it was a nightly CI. On the left side, we can see Project Claire. I did wake up at 4 a.m. to record this. I do appreciate the effort. And on the right side, we can see the repo repair workflow, waiting for the artifact to be available. In a few seconds, okay. So the repo download the artifact, created a branch, used the token, and you can see by now the job has ended. That means the token is invalidated, but I managed to use it nonetheless. And let's see the branch that we managed to create. Cool. So we see the new branch Impala, which of course wasn't part of the repository. So that was cool, but I wanted to win more and more races, and sometimes I lost depending on how big was the artifact. So I did some optimization, some tweaks, like extracting only the files I needed because artifacts were compressed, and sent a lot of requests per second to identify exactly when the artifact is available. It was crucial. And I did some communication tweaks like disabling certificate verification and remove unnecessary headers. And it got me to win this race against Ubuntu. It's a component that ships out with every Ubuntu called ADSys. It's used to integrate with Active Directory. And I've managed to create a new version of it called Drunk Duck. Trust me, you don't want to download this version. And in the aftermath of this attack, I managed to basically avert a massive supply chain attack. I managed to compromise Firebase by Google, which has 1.6 million projects references on GitHub. As you can imagine, if I take a look at your phone, I'll probably see some apps written with the help of Firebase. We already discussed about Ubuntu. This is a major distribution of Linux. Project Lair. Cyclone DX is a famous scanner by OWASP, a respectable security vendor. I managed to compromise several repositories by Microsoft used internally by their developers, and AWS OpenSearch, which is a popular service by AWS. Now to the good news. All you have to do to mitigate this attack is basically change one line of code. Instead of using the original upload artifact, you can use a tool I wrote, a GitHub action basically, it's called upload secure artifact. And what I did basically is integrate a layer of secret scanning inside the upload process of the artifact. So if it found any secrets being uploaded, it will block the upload and fail the pipeline. You can try to use it, it's free. This is how it looks like. Found GitHub token, fails the pipeline. And some takeaways before we end this talk. I can't stress enough how important it is to reduce your workflow permissions. It can help you mitigate against this attack and many others like command injection, PPE, whatever. So do it. Integrate artifact scanning as part of CI/CD. You can basically use my solution or any other. There are plenty good open source out there. And as security defenders, we have to see the big pictures from code to cloud in this case, because often the vulnerabilities will reside in benign features like this one. Thank you very much. If you have any questions.
Any questions?
Was there a response to GitHub on how actions could be re-architected or redesigned?
Yeah, so GitHub basically said it's up to the users not to upload secrets within their artifacts. I think this response is somewhat limited because they can offer secret scanning as they do in other components of their ecosystem, but they don't. They also can change the behavior of the action checkout not to persist credentials by default, which is something that is lesser known by the users. I wasn't aware until I started this research myself.
The actions runtime token variable, how did you find it?
So going through logs, I noticed the environment variables, and it is lesser known, by the way. It's not formally documented, this actions runtime token. But once I've noticed it, I start to dig around and see how it is being used. So I reversed a little bit the upload action, the original action, and I noticed what is the usage of it.
Thank you very much.
Thank you.
Yeah, I'll leave the door. Little trap music doesn't, add to the presentation. All right, good afternoon and welcome to B-Sides Las Vegas, Common Ground. This talk is titled, Free Your Mind, Battling Your Biases. I have a few announcements before we begin. We'd like to thank our sponsors, especially Diamond sponsors Prisma Cloud and Vanta, and our gold sponsors, Adobe Project Circuit Breaker. It's their support along with our sponsors, donors, and volunteers that make this event possible. These talks are being streamed, and as a courtesy to our speakers and audience, we ask that you make sure your cell phones are silent. Just common courtesy. If you have questions, I will walk around with a mic and give it to you. Please just speak into the mic so the people on YouTube can hear you. And with that, here we go.
All right. Is this an appropriate distance? Everybody can hear me fine? Perfect. Yeah, so this is Free Your Mind, Battling Our Biases. I'm Dade. I'm a staff security engineer. I don't know if my slides moved, so just somebody thumbs up. Perfect. All right. I'm a staff security engineer for a fintech startup, independent security consultant on the side. I have a background in red team work at companies like Oracle and Intel, which will be a little bit relevant later on. And if you're interested in more about me, you can find basically all my links at xda.de. Quick disclaimer, this is not a technical talk. If you're here for the latest buffer overflow in a poorly written C program, this is not the place for you. This is a talk about biases, the unexpected benefits of being a beginner, and changing the way we interact with our colleagues and peers. And now I have to actually look at my slides. Cool, now we are where we're supposed to be. Before we get started, I want to take a brief informal survey. I'm going to ask a couple questions, and I just want you to raise your hand if the question applies to you. Have you recently done something that you later thought was dumb? Have you recently refrained from asking a question because you were afraid people would think you were dumb? Have you recently been annoyed when someone asked a question that you thought that they should know the answer to? And have you recently refrained from sharing a piece of information because you assumed that everyone already knew it? It looks like we're all somewhat aware of our own biases at this point, so that's great. I tried to pick some that were more likely to be common in more experienced people, as well as people like who are more beginners are going to feel things. So I'd like to start off by talking to the beginners in the room, the people who are new to the industry or even just new to their current job. We're going to discuss some common feelings and how they can be associated with various cognitive biases, and then we'll chat with the more experienced folks, and we'll end with a technique that I think can help us all battle our biases more easily. We're only going to take a surface look at most of these because I had the audacity to submit this as a 20-minute talk before I started writing it. Hopefully it's enough that if you're interested, you can go look them up yourselves. I personally found a lot of value in understanding that several things that I felt and things that I believed were common enough that they not only had names, but they also had Wikipedia pages. So I wanted to start with this phrase, always be the dumbest person in the room. I got this advice a lot when I was younger, and I think a lot of business guru type people will still give this advice today. An alternative to this might be, if you're the smartest person in the room, you're in the wrong room. The idea here is that we surround ourselves with people who are better than us, and we will get better by proximity, loosely. I speak from experience when I say that this works really well if you want to rapidly level up your own abilities, but it's also really exhausting because you're going to constantly feel like you're behind all your peers. It can work well, though, and we're going to explore a few unfortunate side effects of holding this belief about ourselves. As a beginner, we're not burdened by the curse of knowledge. We know what we know, we probably don't know some of what we know, and we definitely don't know what we don't know. We don't have years or even decades of historical context around any given decision or around any given problem. We look at it with completely fresh eyes and think of solutions completely unburdened from the shackles of reality. This can be a superpower if we're in an environment that'll let it flourish, but it can also be a source of a great sense of shame and disappointment if we're in a toxic environment. I mean, if we're the dumbest people in the room, that would imply that we're the least valuable person in that room. And if we're the least valuable person in the room, then asking a question might just be a waste of everyone's time, right? I mean, they have years of experience. Surely they've already thought of whatever dumb thing that I wanted to ask. If we're the dumbest person in the room, then when someone else says something, they must know what they're talking about. Even if we don't understand it, it must be right, right? I mean, they're the authority, aren't they? But what if everyone feels this way? What if every one of us feels like we're the dumbest person in the room? Then we're all agreeing to whatever happens to be said, regardless of if it's right or not. We have created a bandwagon effect that just leads to worse decision-making in the long run. I think it's important to remind yourself that you're not alone. If you have a question, there's a good chance that you're not the only person who has that question. Or maybe someone else had that question a few weeks ago and they can help answer it for you, which helps you and it helps them to reinforce what they learned. If we choose to not ask that question or to not attempt that new project or not commit to a project because we think we can't do it, we're engaging in a form of self-handicapping. If we stick to only doing the things we know we're good at and never attempting to do something that challenges us, that's self-handicapping. Self-handicapping can help preserve our self-esteem in the short term by helping us to avoid perceived failures, but it can also hurt our confidence in the long term by preventing us from experiencing meaningful personal growth. When our minds are free of assumptions about how a system works, how something should work, we're free to be curious and experiment. We're free to ask questions, we're free to try new things, we're free to experience growth and development. But we're also free to be wrong. In fact, we're probably going to be wrong a lot. But being wrong isn't something we should fear. Being wrong helps us change the way we perceive the world, perceive the problems that we're facing, and helps us to overcome those problems. When I was in 3rd grade, I did a report on Thomas Edison. I didn't know all the things I knew about him today, but to a 3rd grade nerd, he did seem like a good subject for a report on a historical figure. One quote, however apocryphal and paraphrased it might be, has stood with me ever since. I've not failed 10,000 times. I've not failed once. I have succeeded in proving those 10,000 ways will not work. This quote captures an essential reframing of the concept of failure, reframing of the concept of being wrong. Being wrong doesn't mean that we're not successful. Being wrong is not, it's just one stop on our journey to success. It's a great way to reinforce what's right once we eventually figure it out. There's another concept in psychology called the shared information bias, which basically suggests that a group of people will spend most of its time and energy talking about things that everybody already knows and spend very little time on the things that only a few people might know. This has some interesting business impacts if we think about it. Like if you're having a meeting and you want to make sure that the right people are in the room because you want to make the right decisions, you want to reach some consensus and move the business forward. But in business, we don't really get the luxury of just sitting there and discussing the merits and shortcomings of every possible solution before we move forward. It also means that sometimes we're neglecting to make the best informed decisions. Selecting the right people for a meeting is hard and relies on my understanding of what other people know, which is flawed. It leaves out people who might know a great solution but weren't included in the meeting, or maybe they weren't on the email thread. I don't think there's one clear solution to overcoming this tendency. It's going to be a game of balance because we can't just entertain every idea that everyone has before we make a decision. We can't invite everyone to every meeting. We could write documents and make them more widely available, but we can't ensure everyone's going to read it. And in fact, probably most people won't read it. So is there still value in writing it if no one ever reads it? If CrowdStrike crashes a Windows server in an airport and no one's around to take a picture of it, did it really happen? So if you're an individual contributor like me, you are probably more inclined to scoff at the idea of having to write down every proposed decision, the context, the consequences, et cetera, because the more nuance that we understand about a problem, the more we realize that we will basically never stop writing if we try to do that. If you're a project manager, an executive, or someone who just really loves formal process, you're probably very excited by this idea, though, and also very annoyed about people like me who won't follow your process. But we should definitely be thinking about how to overcome, or rather counteract, shared information bias. And if you have tools that you've used to help overcome this, I'd really like to hear about them after the talk out there. One amusing note I realized while writing this talk, shared information bias would suggest that every person in this room already knows all the things that I'm talking about, and that's why they're here, because they wanted to hear more about the things that they already knew about. So to the people who ventured outside their comfort zone to be here, I see you and I appreciate you. Switching gears, I want to talk to the more experienced folks in the room, those of us who have put 10,000, 20,000 hours into our craft, those of us who have forgotten how much we know until we're randomly asked one day about some obscure problem and it all comes flooding back to us. As we grow in our field, we become more saturated with various biases. Even if we think we aren't biased or that we experience bias less than our coworkers, that's a bias in itself called the bias blind spot. We accumulate knowledge over the years, and that knowledge helps us make informed decisions about our work. That accumulated knowledge is why we're so valuable, but it also represents a challenge for us as well. Was I ahead or behind? Okay, this is where I wanted to be. Nope, well, this is where I'm going to be in a minute anyways. If we've been in the same environment for most of our careers, whether that's the same job, the same company, or the same role within the industry, we're likely to face the status quo bias, or our tendency to prefer things stay the same because that's what we know. Who here loves Windows Vista, right? That's what I know, that's what we're here for. So ultimately, we become burdened by the curse of knowledge. Contrary to the beginners who didn't have the knowledge, we do, and that makes it difficult for us to see perspectives of people who haven't been popping or patching shells for as long as we have. Even if those perspectives might be better than ours in some regards, we're probably going to have a hard time seeing it because of what our experiences have shown us. We also face confirmation bias, favoring the things that we're familiar with, favoring the things that align with our pre-existing beliefs, and subconsciously leading us away from things that challenge those beliefs. I think several of these biases help steer us towards decision-making that makes it difficult for beginners to be heard. They help steer us towards the same decisions we've always made. They help steer us away from anything that challenges our status as an expert on a topic. But I think we have to make room for beginners. We have to actively encourage their participation, their confidence to ask questions, their sharing of ideas, their ability to approach problems in new and novel ways. Sometimes we have to let them fail, because if we know their idea won't work and we tell them as much, they might not feel comfortable sharing those ideas with us again. We also have to lead by example. Sometimes if we know the answer to a question, it can be valuable for us to ask the question anyways. By actively making the decision to ask the questions that we think others might have, we are encouraging a culture where asking those questions doesn't feel so scary or overwhelming for others. We're helping to make sure everyone in the room has the same information and helping make sure that others are more comfortable speaking up when they have questions or concerns. Our mental models of how systems work are often biased by our experiences and by the knowledge that we already have. In any advanced system, whether that system's comprised of computers, of people, or some combination thereof, it's surprisingly easy for our mental models to quickly become inaccurate. By making a conscious active effort to free ourselves of the constraints of our own mental models, we can look at things in a new light and find interesting ways to improve them. We can think critically about the things that we otherwise take for granted. But making this effort is difficult. It requires going against every impulse our brain is telling us. It requires challenging ourselves at fundamental levels. But there are exercises we can engage in that help these challenges get easier and encourage us to more easily slip into this divergent way of thinking. In 2007, Sir Ken Robinson gave a TED Talk that posed the questions of whether schools killed creativity or not. In that talk, he brings up this idea of divergent thinking, the concept of seeing a lot of ways to interpret a question, which opens up a lot of possible answers to the question. He gives one particular example that I've found myself using a lot over the last 10 years or so. How many uses can you think of for a paperclip? Most people in this room might come up with 10 or 15 most people will come up with like 10 or 15. People in this room are probably a little bit better at that, maybe 40 or 50 uses for a paperclip. But people who are really good at it, they might come up with 200 uses for a paperclip because they're going to challenge the very notion of the question. They're going to say, who said the paperclip was a conventional paperclip? What if it was 200 feet tall and made of rubber? Suddenly, the uses for the paperclip can expand dramatically by just suspending our preconceived notions around what a paperclip is. This is, in my opinion, the essence of red teaming. I think red teaming has nothing to do with hacking computers, though that's the way that our industry has hijacked the term. The actual skill itself that makes someone a valuable red team member is their ability to think divergently. Their ability to look at systems and problems and think, what if X was an X? What if it was A? When I got interviewed for my first red team job, one of the interviews revolved around a scenario in which I was an electrician. In front of me was a light hanging from the ceiling, and behind me is a light switch on the wall. The light's currently on. List 10 ways to turn the light off, 10 components of a functioning light, and 10 ways to tell if the light is off. And finally, 10 ways to prevent someone from being able to turn the light off. This scenario originated from a document titled Jack of All Trades, which dates back to 2001, created by Pete Herzog. Its stated purpose is to teach security professionals to think outside the box and learn to use their knowledge in different ways. It puts people into scenarios that they're not likely to have a lot of experience in, and then requires that they come up with answers based on those scenarios. I think this is a great example of an exercise that helps to develop our divergent thinking skills. It has formed the structure of dozens of scenarios that I've used in the past, tailoring these questions to be more appealing to the audience. About 6 years ago, I was visiting home and was asked to come speak at the local career tech center about my career in security. I had purple hair then, not quite as many tattoos as I do now, and I showed up in an all-black outfit with like this really long extra black hoodie. I look kind of like I got trapped somewhere between a Hot Topic and the Matrix. I talked to the kids about my experiences in school, as well as experiences doing red team work for a large tech company. I got to demonstrate the perils of plugging in random USB devices, such as the USB rubber ducky, as well as the USB killer. To this day, I'm very grateful for the generosity of the class teacher who let me destroy an old machine with a USB drive just to show it could be done. I like to think that he also learned about the perils of picking up random flash drives that day. But I also used the opportunity to give a talk to the students about divergent thinking. I gave them a scenario not unlike the jack-of-all-trades electrician scenario, but more tailored to something that might resonate with them. You have a test next Friday. Does it say that on the screen? Cool. But the new Call of Duty also comes out that day. How do you get out of taking the test? How do you get your friends out of taking the test? How do you get the whole school out of taking the test? I gave the students a few minutes to jot down some answers to themselves and then asked for volunteers to share some of their solutions. The initial answers were kind of boring. I'm going to try to convince the teacher. I'm going to stay home from school. I'm going to convince my parents I'm sick, that sort of thing. And then one student broke the divergent thinking barrier and proposed that he would go around and break all the printers in the school, because if the teacher couldn't print the tests out, then you wouldn't have to take it. That's when the floodgates opened. I think that the kids started to feel more comfortable sharing their more creative ideas. One student said he would put raw fish in the HVAC system, crank the heat up, and break the knob off. Brutal, but I appreciated it. Another student said they'd cause a car accident to take out a power pole nearby the school the morning of the test. If the school had no power, they probably wouldn't have students come in that day. Once the barrier of the conventional was broken, the students probably came up with 4 or 5 dozen ways to get out of taking the test, and I've never been so proud. So I wanted to actually take some ideas. How much time do I have left? Like 3 minutes? 3? Does anybody have an idea for how to turn the light off? Am I 10 ways to turn the light off? Yes. No, this one, okay. 10 ways to prevent someone from, or 10 ways to turn the light off. Anybody have an idea? What? Throw a shoe at the light, yes. Somebody said hit the breaker.
Get a job at the electric company, become the boss of that electric company, and then shut down the whole power grid.
That's what I like to hear. All right, on the flip side, what about 10 ways to prevent someone from turning off the light? Any good ideas? Tie them to a chair. Smallpox. That will do it. Frame them for a crime and get them arrested. Yes, create a guard. That's like the answer that I would have expected to hear first, which proves that we're at a hacker convention. So I wanted to give a special thanks. Before I wrap things up, I just wanted to acknowledge Toby Kohlenberg, who taught me what it means to be on a red team and routinely encourages me to challenge my own assumptions and ideas. Toby's the one who gave me the electrician scenario originally and showed me the jack of all trades questions, and he offered me my first red team job. I'm really proud to consider him a mentor, even if we don't really talk as much these days. I also wanted to give a special thanks to Kelly Shortridge, who inspires me and who encouraged me to explore early ideas of this talk, as well as whose ideas have helped shape my own beliefs around security and challenging the status quo of the industry. Challenging our own mental models plays a key role in her book, Security Chaos Engineering, which I highly recommend reading. So to wrap things up, I hope this is what you take away. As an expert, go out of your way to ask questions that you think others might need to know the answer to, even if you already know the answer. Ask to clarify acronyms. Ask to clarify assumptions that people are making. You can lead by example and pave the way to a much more productive and informed team. As a beginner, be curious, be inquisitive, and don't be afraid to be wrong. If someone says something that you think is wrong, ask them to clarify. Don't assume that just because they have 20 years of experience that they're automatically right. Seek to understand why they believe what they believe. Finally, and most crucially, engage in divergent thinking. Challenge your assumptions, challenge your own beliefs, challenge your own mental models. This is how we become better, not only at our jobs, but as people. Thank you. Right on time. Questions? Concerns? Does anybody have more creative ways to turn the light off or tell if the light is off or whatever? Yeah. Yes, they make the PlayStation solar powered. Make it bike powered, so you have to exercise to play Call of Duty.
you something smoky to for you. I'm just trying to give you something. I'm just trying to give you something smoky to for you. I'm just trying to give you something.
Alrighty, good afternoon and welcome to B-Sides Las Vegas Common Ground. This talk is Cyber Harassment by Laura. A few announcements before we begin. We'd like to thank our sponsors, especially our diamond sponsors, Prisma Cloud and Vanta, and our gold sponsors, Adobe and Project Circuit Breaker. It's their support, along with our sponsors, donors, and volunteers, that make this event possible. These talks are being streamed live, and as a courtesy to our speakers and audience, we ask that you check to make sure your cell phones are set to silent, be respectful and all that fun stuff. You do have a mic for crowd questions. We'll go around and pass it on at the end. Speak into the microphone so everyone can hear you. And with that, take it away.
All right, let's see how this goes off of 3 hours of sleep. Yeah, it's your fault, by the way, Art in the back. You started it last night. All right, so I'm LJ. This is the second version of the cyber harassment talk I started back in the day. One of the individuals that actually helped me start this is sitting right there. That would be Noobs. He is wearing the masturbation racing shirt that we'll get to later. So, with that. So who am I? I am just a human like everybody else. I am semi-hug enabled. I love animals. If you've got cat pictures, please send them to me. I love to see them. Dogs are welcome as well, and maybe some drop bears. So I have also been the lucky winner of manifesto emails that could literally be put into a coffee book or maybe just a really great novel of someone trying to take every ounce of my life and blast it to the entire world. And after giving this talk the first couple times, it's been really interesting how many times I've gotten a cease and desist from random people who think this talk is about them. So just for reference, if you ever think this talk is about you and you need to send me a cease and desist, you might want to look internally and figure out whether or not it is a you problem. So as far as who I am and who I'm not, so not a lawyer, hired one. One of the reasons this talk was born is it cost me $46,000 to get a protection order. I am not kidding, that is the normal average cost of obtaining one when it comes to cyber harassment. I'm also not a therapist. I hired a stellar one. It's something I highly suggest to anybody who's going through this or a child who's going through this. It's astronomically important for people to have somebody to talk to, and so I would lean instantly on a therapist versus a friend, because sometimes you don't know what your friend's triggers are, and you may actually cause them more harm by talking to them about things, and it will end up not helpful. So the definition of harassment in general is very interesting. So I wanted to actually make this version of this talk much more audience involvement. So anybody here want to tell me what you would feel like was a cyber harassment to yourself? I will give you my 2004 black hat badge if you tell me what you feel like would be considered a justifiable protection order of harassment. Anybody willing to do it? Come on, Art, do it. Love you. So it is very interesting, right? If you feel unsafe, if you genuinely feel unsafe about something that someone is saying to you, you have every right to then tell that person to stop doing that. You have every right to say, I am not, comfortable with what you're saying. In the same sense, if you have a friend who is posting things online or sending out emails or Discord or however many thousands of ways you can send people messages now, if you find that to be uncomfortable, you have every right to tell them, hey, what you're doing I feel is toxic and I think you should stop. What people don't understand, though, is to then turn that into a court and a protection order, you do need a preponderance of evidence that that is doing that. And that could be a lot of different things. And what's very interesting is it depends on who the judge is. So my case was obviously very different than other people's cases. I also don't know if the judge that I had happened to have that happen in their life, and that's why they were much more, listening and reading over my case, where someone else may say, this isn't a big deal. So as far as defining harassment, you need to define that for yourself and then decide what you're willing to fight for and stand up for. And that comes to yourself as well as what your people around you are doing. The thing I have heard the most throughout both of the cases that I assisted with as well as my own is that they think it is complete freedom of speech to go online and to absolutely blast somebody. That is not true. Like, if you were to walk into a crowded movie theater or where we are sitting right now, and one of you were to yell fire and someone gets trampled on the way out, it absolutely is the person who yelled fire's fault. So people need to pay attention to what that actually means as far as who got injured from the words that were coming out of your mouth or on text. So this one's been a little bit interesting, and it's changed throughout from the first time that I gave this to now. So from the first time that I gave this, one of the big things is when this slide was created by me, I wanted to ensure I did not go into any details of how you would do this, because I'm now just weaponizing anyone who's watching this. One of the things that I never expected coming out of this is that what if it is someone who actually set up your network for your business or your home, and then you guys get in some sort of a weird argument, maybe you say no about something, you set a boundary, and now they have all of your information. It is damn near impossible to prove that at that point. So if I had a time machine, I 100% would go back to the ass hat that, sorry for the whoever's listening, if you're children, said that words are not a big deal, and that, the sticks and stones may break your bones. That, at this point, is not the way it works. I know I meet with kids on a regular basis now throughout schools and scouts and all sorts of different events, that words they would rather get punched in the face by somebody than have someone dogpile them online. So that is not a statement that should be made anymore. We've far outgrown that. So this one is a new situation that came up with me that was interesting. And now that I know you guys don't want to participate, we'll just have to. So imagine my surprise as I'm sitting at my house and I get served with a non-legal piece of paper that was super funny, and it might as well have been in Comic Sans. And that person was now claiming that I'm the harasser. Even though I was assisting somebody with a case, they are claiming I am the harasser. So now they're going out and they're spoofing my phone number, they're creating emails that are just my name, and they are going around and telling the entire InfoSec community that it is me that is doing it. The problem with that is, once that lands you in a courtroom, it is now costing you an exuberant amount of money to prove that you're not even the one that did that in the first place. And it is an endless battle that, unfortunately, as we get further down this line, that is what absolutely creates that helpless mentality and soul crushes people. So that's the part where this community absolutely needs to start leaning on each other, of the rule of if it's domestic, we don't get involved has kind of gone out the window. When you are 100% aware that one of your friends or someone you work with is doing this type of thing and you don't open your mouth, you are just as much at fault as the people who are doing it, in my opinion, because you are now not setting that line and that boundary, and you are basically brushing it under the rug, where you don't necessarily have to cause a big drama llama over it, but you can now turn around maybe to the person, instead of having them spending their entire life savings in their 401k, and assist them in getting them the help that they need to be able to get the case to where it needs to be. So these are snippets from the emails that I was receiving and my lawyer at the time was receiving. So you can tell from the bottom one, it was somebody in our community. There is not a day in the world that I will tell you who it is during the slide deck, for many, many reasons, one of which is I hope they get help and they come back. They were actually really a good person in the beginning. So this is a situation where you're receiving these emails, and what do you do with that? What do you do with this information when you no longer feel safe in any way, shape, or form, because you are 100% aware that if your cell phone number is on your business card and your bill goes to your house, now everything is out there. So you're looking at these little tidbits of information and realizing that these quotes may seem like just words to some people. These quotes are what a judge looked at and was able to issue a lifetime protection order for not only me, but also if I have a future spouse and children. And not minor children, my children in general. So during the entire process of when I was gathering up all of those quotes, all of the emails, when I was trying to talk myself out of making a coffee book by just actually, redacting some things and submitting it to an editor, I was looking at this going, what do I do? There's many, many, many people in this community that had absolutely no idea I was going through it. And one of the reasons was I didn't think anybody would believe me. I also didn't think that the words mattered or the large amount of stress mattered that was happening. I didn't think that what was going on with my child was really something that people would care about. So I just kind of sat and idle, and I stored everything I possibly could into a folder that I did not look at again. It wasn't until I had a lawyer take a look at it who stated to me that I absolutely had every right to get a protection order. So during that process, though, that's where your money starts accruing. And once that individual found out that I was looking to get a protection order, they were then filing, I kid you not, around 20-page emails to that attorney, costing me around $350 an hour to read these manifestos. So that's where everything started mattering. I can say if I didn't have a child, I probably would have just stepped aside. But the fact that my son was also receiving letters, my son was also receiving text messages on Steam, it became I don't care what this takes, I'm gonna continue to fight this, and whatever credit card debt I have to go into, I'm gonna ensure that he's safe for the rest of his existence. One of the biggest things that you have to be careful about when you get this protection order is the wording that's in it. My original protection order was worded minor children. So at any point, my son would have had to go back and fight that fight again as he turned 18. So I made sure that it just says my child in that, or children in general. I can tell you when this court transcript hit my inbox, I reread this over and over again just to be able to sleep at night, because it was the first time I felt like someone actually understood what I was going through, and it was a complete stranger that was standing there, like literally judging what I was doing. During this process, when I presented all the evidence at court, he actually turned around, pulled out 8 to 10 books, laid them out on the table, and had to find where the quotes and the threats and the harassment matched the laws at that time. I got extremely lucky that judge was willing to do it. He took a lot of time to sit there and really figure out what matched where. Not everyone has that luxury. Not everyone's gonna have that happen. So the fun factor where I said you might as well have served me with Comic Sans. So the top part is what is an actual protection order. If you ever have a friend or a family member that is trying to obtain a legal document to have somebody actually stay away from them, it needs to look like the top piece of paper. The bottom piece of paper, and since I have moved, I will say where I used to live, is what the grand, wonderful Oconee County of South Carolina will issue for $15, and they will claim that that is a no contact order. Fun fact, I was given one by someone who actually tries to drive me crazy. And when I laughed with the police officer on the phone, I said, this is an illegal document. He goes, I know. He goes, it's hilarious that my tax dollars are used to serve people with that. So what I did was I asked him, I said, how does one obtain one of these non-legal no contact orders? And it was go down to the county clerk's office, you spend $15, and for the lovely tax money that we all pay, a police officer will kindly go to their house and serve them with that. So the reason my signature is on that is I just served it right back to him because I thought it was funny. So, now we both have one. Merry Christmas. So, I'm the one who laughed because that top one is something that, again, it took me an exuberant amount of money and time and evidence and getting it actually not forensically sound, but provable that it was from that individual. One of the things you need to look at if you're being harassed and you really want to have that is you have to have already established that that's that individual's email. You have to already establish that that is that individual's account. And then you have to, on top of that, make sure your lawyer is willing to fight and prove that they were actually accessing it at that time. So it is extremely difficult to prove a harassment case. That is exactly why for InfoSec community, if you know somebody's doing it, you've got to reach out, you've got to do something from a non-legal sense, because not everyone has the money to throw down to do this. So with that, this is a no funding and lost hope case that I was helping someone with last year. This one was a very interesting situation when it came from, I joked around calling it spy versus spy for a while. So it was a situation where someone was a business owner on a small main street. There's literally 100 people in my town, give or take, Old Town. And this person who owned the business every night would go home and would come back, and every morning, every single device that attached to her network that day would be blocked. So she's a very non-technical person. She didn't understand what was going on. She's hotspotting off of things. She finally calls me and says, I know you don't want to get involved because I happen to know the individual that she was pretty sure was doing it. She's like, she was like at her wit's end. And so I go up and I look and I log in and all the MAC addresses are blocked. So I go in, I change every password. I do all the things that they teach us to do. You know, mine is turn it off and turn it back on again, because I guarantee you that was not going to fix the problem. So I go through and I do everything we're taught from a base level. I go home that night, I come back, same thing. The next day I'm up there and I'm actually working with her from my laptop because she was literally scared of what was going on. This person was coming back and forth from her work, front and back all day, war driving. And again, 100 people in this town, I promise you weren't getting any unique IDs going back and forth here. But every time that they were about 5 minutes out, 50 feet out or so, it was really funny because her entire internet would drop. And as they would walk past, it would be dropped, and then as they would continue on, suddenly it would come back. There is not a single police officer in a small town who has no tech at all background that is going to understand what's going on. And there is no world that I can stand there and even try to explain it to them, because they now think that I am just crazy. So she's going through this and back and forth. She's taking photographs. She has emails. She has text. She has everything that I would have assumed that I had. She goes into court. She has no lawyer. She can't afford one. He crowdsourced the InfoSec community. He was able to afford a lawyer. That lawyer said that every single piece of her evidence had to be forensically sound, as if it was a dang murder charge. She tried. She tried to get the notarized letters. Her and I worked on it. Short of somebody out of a movie, you know, running up behind him while he's on his laptop next door, changing things on her network, I'm not going to be able to catch this person, nor am I probably going to be able to do that. So she sent that email to the court saying she was done. She absolutely was done. She could not take it anymore. I actually got her permission to say this, but she did at that point need to seek help for an extended period of time somewhere else. She could not even be in her home because of the amount that she was fearful for taking her own life, and the amount her depression had gotten because she couldn't function just at a normal day-to-day basis. So she sent this saying, like, I am done. I am out. Once she did that, she thought that's it. It would get dropped. They would stop. However, that person asked for that charge to be dropped, but only with prejudice, which means she can never charge that individual again with harassment. So after that, it got far worse. She can never take him back to court. She actually shut down her business and moved her entire house, her husband and her children, to get away from it because she couldn't take it anymore. Then during my research of what was going on with my own case is when I came upon this case. So this is where I really started having a big outreach on going out with children and talking to parents and finding out that my case as an adult already put me into a state of depression, that my hair was falling out. Like, there was multiple times that I couldn't really get out of bed in the morning, but I had to because I had kids. And I find multiple cases of children ranging from the ages of 8 to 16 who have taken their own lives over cyber harassment. So as far as her case, it was a complete catfishing situation of she was a little girl who had never had a boyfriend, and there she was getting an online boyfriend who absolutely was her world, and she thought everything was fantastic. I highly suggest going in, when I share the link in the next slide, look at this person's, what the mother has done because of what happened. She has created such a foundation where you can go through and actually get their assistance to go out and have these same type of talks with the schools and PTAs and other kids functions and honestly, even with your adult friends. The fact that no one would ever think that a teenager would hang themselves over having an online relationship is something that maybe from the 50s to the 80s, we thought this is fine, like this is just words. What is going on now with the kids is that they're getting harassed in school. They normally would come home, and that would be a break for them. That would be a mental break. They hopefully have a good family, or they have good friends, or they can take a moment of silence to themselves. That's no longer a thing when you have a laptop and a tablet and Steam and various other things. My own son does not have Facebook for many, many reasons. He's a very sensitive soul, and I just don't think that I need him to be dogpiled on that. He is on Discord, he is a gamer. The things that come out of his mouth on games, I'm not very proud of. But like, we have had discussions actually about when they're all talking like about each other in a horrible way. Ensure that your friends do think it's funny. I'm probably one of the most sarcastic assholes you will ever meet, but I do make sure that my friends like are not in a state when I say it, and if I do feel I've crossed a line, I make sure I check in with them. So I do give him that lesson of it's fine to be online and it's fine to do that with games, but you have to actually know who you're talking to and your friends and what type of influence you have on these people. So this is the foundation that she has and the facts of what is going on. This was one of the best things that I found during my harassment case because it actually gave me a situation where I felt like I wasn't the only one who's had this go on, and I also wasn't the only one who had the feelings about what happened. So it's one of those things where you are in this state, you're going through something, and you say to yourself, I'm done with this, and you think you're the only one in the world that felt that way. When you stumble upon this, and I ended up talking to the mother, and I talked to other parents in the cases, and some of them didn't want to be named for obvious reasons, but one of them said it was fine to discuss it, but it was an 8-year-old out of the Minnesota area that committed suicide over cyber harassment. They literally felt as an 8-year-old child they had no other option because they felt like their entire life had been dogpiled online. So that brings you to, these are the statistics of what is actually going on out there, not only with adults, but with kids, and we need to get ahead of it. We need to find some sort of laws that can wrap around this, or some sort of groups that can assist. Somebody can go out and take what this mother has already started and take her to the finish line of, you know, creating more support groups of saying, if you are seeking some sort of basic, you want someone to get charged for harassment. They may not get charged for the suicide, unfortunately, but they could still get charged for the harassment. That is something that we could reach out as an InfoSec community and be able to start helping people do. There are things that are changing. I don't know if many people remember the case, but there was a case where a woman was constantly texting a man to kill himself. He drove off a bridge. She did get charged. So it is coming around, but it's people who then speak out of it and find out about it, and they're willing to fight for it. And I promise you, it is ridiculously hard. I get called multiple times per month on different people's cases, and I sit there and I listen, and it's extremely triggering. But if I'm the only person that they have been able to speak to, I would never turn off the phone for that. So it may not be something that you think you have time for in your life, but make the time. The suicide rate for the kids, the fact that it is 2 times higher, is something that a lot of people don't want to hear. They don't want to wrap their head around it. And so that's one of the things that find a way when you're going in to talk to your own kids, maybe friends of kids, adults. I was there. Like, I literally remember the final email that I got that was the push over for me. And the only reason I'm standing here today is because there happened to be a friend standing next to me who watched me fall apart while reading an email. I cannot tell you what would have happened if they were not physically present when they watched my face go from a normal, happy person to white as a ghost. So when the feeling helpless part, catalog that evidence. Don't read it again. I can tell you one of the hardest things about giving this talk, because every time I do it, I have to go back through mine. I have to go back through mine, I have to go back and look, I have to look at what was said or what was done, how much I'm willing to actually stand up here and say. I've had multiple threats that the entire manifestos will get released if I ever give this talk. Those manifestos have a wide range of falsified information in them, ranging from that I am an extreme drug addict to I abort multiple children. There are massive amounts of false information in this that could be released, but I'm still standing here. And I'm standing here because of the fact that I know that that person standing next to me, that person who watched my face turn white, that person who was willing to fight for me at that moment, I want to be that person for someone else. I want to pay that forward, and I want to make sure that other people feel comfortable enough to pay that forward as well. One of the other things that a big, big thing when you're sitting in court that was very hard for me. Anyone who knows me, I am a lot of a human being. I have feelings as the days are long, and one of the things I had to do in court is you have to sit there and be completely emotionless and all factual. What I learned later after that is that if I needed people to actually hear what was going on with me or what was going on with cases that I was working, is I also had to be that way with other people. If I was crying, you would be appalled by the amount of people that wouldn't even listen to me and wrote me off as just being dramatic. So I had to actually become this like extremely cold person if I'm working on this to be able to get this information out there. One of the other things that I did for myself during this process that a lot of people were unaware even exists is FMLA can be used for your own mental health. I thought it was just for babies. Like, I had absolutely no clue that if you were going through something in your life that you could take FMLA. Your work should be saying it, but they don't. You have to research it yourself. You have to have somebody who tell you that. It is something that CEOs of companies should put out. They should absolutely tell someone if they are at a breaking point in their life, it is perfectly acceptable to take FMLA, take the time off that you need, and to come back. I'm very fortunate that I have been surrounded by amazing companies that I have worked for, that was available to me without a fight at all. Nor should it ever be a fight, but people do obviously have, you know, oh, you're taking 3 months off, or what is it for? You also don't have to tell them what it's for. The other part is the turning to someone supportive. There are a crud ton of people in this room right now that I have turned to during this that have really helped me out. There are other people that actually saw me in a certain state and turned their backs on me, and it put me in an extremely different situation. So I learned very, very carefully who are the people I can go and talk to, who are the people that I can feel supported by, and who are the people that genuinely have no bandwidth to listen to what's going on. And that is okay too. That is one thing that I have learned that I have had to do for myself. It is okay to tell someone, I don't have the bandwidth to talk to you about this right now. I'm not going to be the best person for you. I'm not going to be the one who's going to help you through this, but let me get you to where you need to go. It's okay to not be able to be that person for someone. What's not okay is to make them feel they're just being an overdramatic crier in the corner and leave them there. So the keeping yourself safe part is what is very difficult. So when I say that the justice system can work for you sometimes, yes, it can if you have money. That's the problem, right? What do we do with that? Do I find a way to start a foundation for these cases? Do I, start educating more people on how do we help each other so that the bankroll is not that high? I'm honestly standing up here telling you, I don't know yet. That is not something that I have been able to figure out over the years. The protective orders, I do highly suggest getting them. If you have what they call, and I butcher this word every time, a preponderance of evidence, you can obtain a protective order. It might only be for 3 months. Your first round of protection orders you go into, it is temporary. If you can get a permanent one, you do need to sit there with a large amount of evidence that is forensically sound to a degree of that judge. What all of us sitting here considers forensically sound is going to be wildly different depending on the judge that's there and the lawyer that's there. So hire an attorney that has a cyber background or has cyber training so that they can understand what you're looking for. As I've said before, definitely look into getting that FMLA. Take a break. It's okay. It's okay to take that break. Your job will still be there with that FMLA. And if it's not, probably shouldn't have worked for that company in the first place. They're not there to support you. The ones that's the hardest thing to keep yourself safe is do not block that person. Find a way to send those emails somewhere else. Find a way to maybe have a friend of yours buffer that account. Like when it came to the woman that came to me case with her network issues, I was kind of funny about it. I just went ahead and bought her all new network equipment, kept the old one standing, and let him keep hitting that one all day long. It was great. I added so many different devices to that. He was so busy trying to figure out what to block. It was really fun for me. But she sometimes. So this is the biggest part of, I redo the statistics at the bottom here because I really do want people to understand that this is not something that's happening to a few people. This is happening to a lot of people around us every day. And everyone's going to handle it extremely differently. One kid being called overweight may take that extremely differently than someone who comes to me and says it, or someone comes to my son and says it, because my son will constantly throw the joke of something along the lines of I'm built for comfort, not for speed. So like there's some kids that can take it. There's some kids that can't. So really paying attention to that cyberbullying and what any human being who's having it happen, no matter their age range. And the biggest thing I have to drive home is speak up if you see someone doing something toxic online. It is amazing to me on how many times I have had people tell me, hey, I saw something about you. I didn't want to tell you because I was afraid I was going to be the next Facebook post of them. And I always say to them, like, well, did you tell them to stop? Like, what happened? And they would say, oh, I don't want to get involved. I don't want to get involved in that. And that's everything ranging from somebody stating where I work, somebody stating where I live. I've had somebody levelly call me a rapist online, trying to get under my skin. That's also been sent to my hacker families. I have had that spread around town so that people come up to me and tell me that I can rape them anytime. Like, it has been endless for me on the harassment, but the amount of people that I have had to help me and support me through it are my saving grace and why I'm standing here. And I promise you, you have friends in your group that are going through a similar thing in one way or another. They're just not probably speaking up about it because they don't want to cause drama. But these statistics are extremely real and they're going on all the time. One of the biggest things I did wrong was, like the case with the foundation, I continuously read and kept going back over.
Bad. And Washington, D.C. itself has, out of every 10,000 people, about 7.8% are lawyers. That's 780. In San Francisco, out of every 10,000, the same number, only about 65, about a little over half percent, 65 are lawyers. So what's wrong with that situation? Do you see what I mean? Same number of people, and you've got over about 12 times as many lawyers in D.C. as here. So, that concerns me. Be careful who you get. That's what I'm getting at, as a lawyer, because there's a lot of ambulance chasers out there, and a lot of lawyers should not even be. They should be disbarred, but they're being protected, and that's why I'm concerned. Anyway, that's why I wanted to mention about lawyers. It's a bad situation for our country right now.
All right, I can go back to drinking now.
Hey.
Woo!
something spooky I'll do for you. I'm just trying to give you something. I'm just trying to give you something spooky I'll do for you. I'm just trying to give you something. Ooh.
All right, good afternoon, everyone. Welcome to our last presentation of the day here in Common Ground. We've got Harriet here who will be talking to us about why she's our Ocean's 11 AI gal. So, yeah, looking forward to that. Before we get to that, I'd like to thank our sponsors, and especially our diamond sponsors, Prisma Cloud and Vanta, and our gold sponsors, Project Circuit Breaker and SemGrab. This is being recorded. We ask that everyone keep their cell phones on silent to be nice, and all those fun, kind things. When we do questions afterwards, I will have a microphone. I will give it to you. You will speak into it. Makes it easier for everyone to hear. With that, take it away. And she's supposed to be doing a shot right now.
That's not a thing here, right? Like, they've given me this very large cup of bourbon, so I don't know about. Oh no, what's that? So I don't know. I can have a sip, but I've got a few more talks this week, so I'll save it for them. Okay, there we go. Okay, can everyone hear me okay with the mic there? Okay, if I hold it, I'm liable to turn into like a stand-up comic, and no one wants that, so it's for the best that we don't go there. But thank you very much for sticking around until 6 p.m., the last session of the day. I appreciate it. I'm a bit jet-lagged at the moment. My flight was meant to arrive last night. I'm from Australia. It arrived today, so I'm feeling a bit woozy, but I think that means that I'll be like very candid and honest maybe, and hopefully I'll remember my slide order. But anyway, I'm delighted to be here with you. So on your Ocean's 11 team, I'm the AI girl, but Guy has a better ring to it. So that's the title we're going with. So our objectives in the talk today are to hack the casino, specifically the AI, the artificial intelligence of the casino in question. So we're going to start with a bit of open source intelligence and recon. We're then going to focus on the facial recognition AI, and we're going to put it in the perspective of AI security. I'm an AI security person. I run an AI security company in Australia. I've been working at the intersection of data science and cybersecurity for about 10 years now. I started in consulting, then moved to a startup. I worked in the Australian government, and my PhD is in machine learning security. And then a year ago, I started Maleva. I'm also online in various places at Harriet Hacks. The social media content I'm not really very good at, but you can find me on X, Instagram, TikTok. Maybe you don't need to check out all of them, but you can find me there. We have a podcast. It's a whole thing, not to be totally cringy. So why the casino? Well, it's Las Vegas. Why not? The casino is a really good case study or analogy for every large organization at the moment who's grappling with this sort of tension of trying to adopt artificial intelligence very quickly, but maybe not necessarily feeling like they understand all of the potential risks involved. And so obviously the casino is one of them. And they have a lot of money, so they need to care about risk, as do many other organizations. So some disclaimers. We had this particular casino's permission. The attacks are real, but I'm not going to show you exactly how to implement them on Canberra Casino's AI itself. And can I get a show of hands in the room of who would consider yourself maybe an AI person? Okay, and a show of hands for the cyber people. Okay, that's what I thought. So AI people, please don't come at me. This is more geared at cyber people who might not know that much about AI security, or it's meant to go sort of from a gentle 0 to maybe 80. I'll be giving this talk at DEF CON as well, and it'll go into a bit more of the technical detail. But this B-Sides talk is a little bit more about the theory side, but with some cool attacks. While I'm here, we're talking about Canberra Casino's permission. So as you can maybe hear from my accent, I'm from Australia. I'm from Canberra. Is anyone familiar with Canberra, Australia? Yes, I hear some some yeses. For those of you who aren't, it's our capital city. A lot of people don't know that. A lot of people think it's Sydney. But Canberra is our capital. It is our political capital, so it's very politically focused. It's a bit like DC, but much smaller. So we have one casino. And fortunately, Casino Canberra were really really accommodating and willing to work with me on this. So Canberra Casino is our city's best casino and our only casino, but don't let that deter you. They're pretty good. If you're listening, you're a great Canberra Casino. Okay. So for the non-gamblers among us, I think I went in with a certain set of expectations around how casinos would use artificial intelligence. But I found that they weren't necessarily fulfilled. So let's just dive very quickly into casinos in general. So they make a lot of money, so they need to care about AI risk, right? They have a controversial history. In particular, in Australia, some of our big casinos have been under quite a bit of heat lately for money laundering and not complying with their regulations. I'm not saying this is true of Casino Canberra, but this is sort of the landscape in Australia at the moment. There have been some royal commissions. Around the world, casinos have been known to have money laundering as a risk, of being able to move money around. That's sort of the nature of it. So in terms of using technology appropriately, it's something they really care about given the landscape that they're in at the moment. They use artificial intelligence. I thought that they might use artificial intelligence quite a bit for, say, detecting card counting or things like that. I realized very early on that actually facial recognition and person identification was the most important use of artificial intelligence. And there aren't that many providers of this kind of AI technology to casinos. Quite a lot of them are the sort of casino chip and card providers themselves. It's a small landscape. Does that matter? Well, we'll get to that later anyway. But facial recognition and person recognition are definitely the most important forms of AI. And that's because card counting isn't illegal. It's considered advantage play, which maybe it sounds obvious. I didn't know that. So you can card count, but you shouldn't do it conspicuously, or you can get thrown out because the casinos are able to throw out anyone they like. And so if you are, ostentatiously card counting and winning a lot of money, they really don't like that. Because the algorithmic bias in the favor of the casino, what I also found interesting was that in terms of hacking an artificial intelligence system, that can mean a lot of different things depending on how you actually define AI. So here's the first bad joke of the day. So when I first told my mum that I work in AI, she said, "Oh, darling, why are you working in artificial insemination?" Because, see, that gets a laugh. It doesn't get a laugh in a lot of crowds. But she works in the medical profession, so for her, that's what AI is. And so for, I think, most of us, we would know that AI is artificial intelligence, but even so, we all have a slightly different idea of what that actually means. So maybe for some of the cyber people, as in terms of level setting, when I say AI security, people often interpret that in different ways. Often people assume it means AI for cybersecurity. Among the AI security folk that I sort of work with, in this context, AI security is the security of the AI system themselves, but that term does tend to get muddied a little bit. So when we think about AI security as a field, it's more likened to sort of cybersecurity when you talk about the actual security of the system itself. And in terms of the potential attacks and vulnerabilities in AI systems, these historically have come from the academic field called adversarial machine learning, which has been around for about 10 years. And the slide that should be showing is an example of an adversarial machine learning attack in the wild. So this is being able to add, for example, specially crafted pixels to an image, or a specially crafted sort of material to an image that can prevent a model from recognizing it accurately. So if you're able to add these perturbations to a stop sign, an AI system that's meant to be doing stop sign detection or object detection can be essentially hacked, so it's disrupted or deceived so that it can't actually recognize the stop sign. So this attack sort of came to the fore with this classic example, which many of you may have seen before. But this is from sort of 10 years ago. It's by this pivotal paper by Zeget and Goodfellow, not to get too theoretical or academic, but it's basically showing that you can add specially crafted pixels to an image, in this case of a panda, to prevent the model from recognizing that panda and instead recognizing it as a gibbon instead, even though to a human observer, they see no difference. And these are specially crafted pixels. They're not random. There are lots of different methods to create these pixels. So in a computer vision example like this, you can see that the noise we're adding is basically that sort of pattern. But all of these methods can be transferred to other fields as well, or other domains that are a bit less obvious for humans to detect, like audio, signals, things like RF, those sorts of fields. So this field of adversarial machine learning is sort of the origin of a lot of these offensive AI attacks. So offensive attacks on AI systems themselves. But when we think about actually hacking AI, or whatever has been known to be, whatever has been referred to as AI in the past, we can go way back. And in the context of casinos, as long as people have been using algorithms, or as long as organizations have been using algorithms, people have been finding ways to hack them. So if we think of an example that we would all know, things like email spam filters, people have always been trying to evade those kinds of algorithms so that they can get spam through. In the context of casinos, a really cool example, I guess, is from things like random number generators. As we all know, random numbers do not exist in a computer sense. You have to have an algorithm that gives you the next number. And so there have been some pretty high-profile hacks in the casino world in the 90s. For example, this particularly big one is from 1995. Ron Harris was employed by the Nevada Gaming Board, whatever that board is called. And in 1995, he was able to predict the next numbers in a game of Keno, so that he was able to win $100,000. And he was found. They were able to go up to his hotel room and find him. But there have been quite a few examples of these kinds of, I guess, hacks in the casino context. Another one you could really consider a hack, in a sense, is card counting itself. Because the whole idea is that the statistical nature of every gambling game we play means that the casino always wins, right? And this advantage that the casino has is different for every game. So things like the slot machines, it can be up to 25% advantage to the casino, and the only reason that's limited is because of regulation, so that it's not even higher. But in a game of blackjack, it can go down as low to 0.4%, depending on the rules of the game. And if you're able to play blackjack according to perfect strategy and then include card counting. So that's a way of, sort of hacking that algorithm as well, so that you know exactly the right plays to minimize the favor in the casino. So thinking in terms of the adversarial machine learning landscape so far, so today, in terms of the number of attacks that you could implement on an AI system, there's over 100. And this diagram, you don't need to worry too much about all the parts of it, except that for every kind of attack surface you have in an AI sense, whether you're talking about a machine learning model like a convolutional neural network, which is a type of AI model that's really good at computer vision, so recognizing images, or something like a transformer down the bottom, which is very good for natural language processing, so think things like ChatGPT. They have different kinds of model architectures, therefore different kinds of attack surfaces, and therefore different kinds of attacks that are more likely to work at different stages of that attack cycle. And these are just a few of them, but in things like MITRE's Atlas repository, which is the MITRE attack equivalent, but for adversarial machine learning, there are over 100 different kinds of attacks listed. So that's the landscape of adversarial machine learning for cyber people. So I assume everyone here has seen Ocean's 11, or you are aware of the premise, or Ocean's 12 or 13 or 8. I don't think I need to belabor it. Basically, it's a heist. So I thought, well, what better sort of narrative structure to have for a talk in Las Vegas than to try and commit a heist. And I'm not, unfortunately, I don't have any George Clooney or Brad Pitt lookalikes in my team. But the idea of this talk is to hack the casino AI that is most relevant to them, which I found was the facial recognition AI. to sort of get to my goal. And what that goal is, we'll also discuss a bit later on. So this is the process I went through. So first of all, we're going to interview the casino staff. We're going to pick our target models. We're going to implement the specific attack that I'm looking at, which is called a distributed adversarial region. We're going to disguise those regions in different ways. And then I guess we'll reflect on it and get some lessons learned or something. So the first step, we want to do a bit of recon. We want to understand our environment. So what I do is I tell people I'm a PhD student doing a paper on AI security, and I want to interview experts. This is very successful. I am actually a PhD student. I've been doing it part-time for a very long time, like way too long. It's very sad. But people are more than happy to chat to me about some of the most intimate AI security problems. People are extremely candid. I'm not saying that's necessarily true of Canberra Casino. They were appropriately candid. But I've been doing these kinds of interviews with lots of different organisations. So Casino Canberra was one of them, which was sort of perfect for this talk. But over the course of the interview process, which is for the PhD and also for the company, so it's sort of nice dual use there, I've already done over 50 interviews of 43 different organisations. And it's all on the topic of sort of AI security and the potential vulnerabilities in their AI systems, and whether they know much about their AI systems or their AI security risks. And as some, initial insights, 94% of those people in the organizations could articulate how they use AI. Basically every organization is using AI at the moment, but only 8% could articulate how they secure their AI. So ability to secure it from those adversarial machine learning attacks I was discussing earlier. So things that would disrupt, deceive, or disclose information from their systems. There's a really big gap there. Now, that's not necessarily the case for Casino Canberra. For them, they're at an interesting inflection point where, big casinos, so the kinds of casinos that are in Las Vegas, already implement facial recognition AI and many other kinds of AI as per course. Like the building has been designed to be inherently AI-able. The way that the architecture is, you have to walk through certain corridors at some point. That's to make sure that the facial recognition cameras can find you. Where you're able to park your cars, just the different thoroughfares, in addition to all of the sort of psychological tricks that are done to keep you in the casino, are there because surveillance is inherent in how you experience the casino. And it was pretty clear early on that facial recognition is the most important way they do this. Even for things like money laundering or card counting, it's not necessarily the AI that is detecting that, but it's the responsibility of the dealer to be able to identify what's going on, identify dodgy people, and then alert the casino so that they can then put it in their facial recognition AI systems. So this is by far the most important use of facial recognition AI. For those casinos that haven't been able to fully adopt that kind of AI yet, it really still relies on their people. So you still have rooms full of people surveilling cameras in real time and trying to hope that they catch the right people based on manual processes, which is really hard. And obviously this is less likely to catch as many people or entities as an AI system would. But then, there's the whole privacy trade-off there too. And just as every organization is, trying to adopt artificial intelligence at the moment, that's true of casinos. It's very expensive, and they really have to sort of make that judgment based on, how profitable they are. So Casino Canberra is going through that sort of inflection point too in that decision-making process. So we move to step 2, and now we're choosing a victim model. So there are lots of different sort of surveillance AI providers out there. These are some open source facial recognition models that exist, just a few of them. There are many. I could also create my own sort of custom model. But at the end of the day, they're all pretty similar because they all are for image recognition. And so they therefore all use this particular type of AI model, a machine learning model called a convolutional neural network. And at the end of the day, that's basically a model that's based on the way that humans are able to identify faces and objects as well. based on our brain structure. So we have input data, it goes through a sort of model of neurons and synapses between them, and then we're able to predict who someone is or what they are. And so in a machine learning sense, that's very much the same too. You have neurons connected by different layers, and there's a training process so that based on historical data, you can predict future output. So regardless of how you decide to, I guess, customize your model, at the end of the day, they all rely on this specific architecture and a very similar training process. And so what this means from an AI perspective in terms of how you actually predict what a face looks like, it sort of compresses, in a mathematical sense, into this space called an embedding space. So all of the higher dimensional data that is captured about faces, if we were to display it as a 2D image here, or if you could imagine it in 3D, it's basically like different clusters of features that are similar. So in facial recognition, for example, it's very much based on the geometry of the face. So how close people's eyes are, what kind of shape they are, relation to the rest of the face. And so you end up with different clusters based on different features you're looking for, and based on how similar the clusters are, a model is able to make a pretty good prediction. The other thing that's unique about talking about artificial intelligence models versus, a cyber system is that if you're thinking about a model, you usually refer to its sort of evals or, lots of different factors, statistical, mathematical, that tell you how good it is at predicting something. So here we've just got accuracy. And these are a few examples of open source facial recognition models and how accurate they are. So they're all pretty accurate. They're all over 97%. Most of them are close to 100%. Of course, how you decide to test this is a question. These are sort of based on research papers that benchmark these kinds of models. However, the thing about machine learning models is that because they all rely on that same convolutional neural network architecture, you end up with these models that converge to the same kinds of features and representations, no matter who is building that model or what organization is creating that process. Research has shown that actually, if you're comparing clusters of models or similar models that are designed to do similar things, they are 95% similar to each other, at least. All of the numbers range from 95% to 99%. So what that means is that if you take two models created by different organizations, by different researchers, if you were to compare what they look like on the inside, they are 95 to 99% similar. And this is true of models created by companies that represent their IP. There's only so many things you can change about a model if it's designed to do a certain thing. So this is an interesting point. But for us, this principle of convergence makes it really easy to attack models, because I can create a model that is almost identical to any other model and then create an attack and launch it against that victim based on this surrogate model. Because the same data plus the same training type basically equals the same model. So the third step is I'm going to create what's known as distributed adversarial regions, and this is the attack that we're implementing here. So here's just an overview of some different kinds of adversarial machine learning techniques that have already been tried in the wild. So we've already got that panda image there. The one in the middle is these adversarial glasses. So someone is able to not be recognized by facial recognition or person recognition by wearing either glasses with this special adversarial coating or a jumper with an adversarial pattern on it as well. The last image I like to show because it's funny, but basically the one with the cardboard box over the person is a study done by DARPA, or rather DARPA created a person recognition model to use in sort of urban camouflage environments. And they asked a team of their Marines to try and hack the model. And basically they were just able to act like not people and defeat the model. So they did things like hold branches and wave them over their heads and put, cardboard boxes on their heads. So anything they did that was a bit outside the norm was able to hack the model, which I like to show because I guess it's not really a sophisticated attack, but these attacks still do work. Now, is this attack a sophisticated attack? I guess it depends. So this is an attack that I created for specifically urban camouflage settings. So the research that I do, well, I started when I was working with the Defense Department. So a lot of it was sort of very focused on sort of military applications and the national security context. And so the idea is that you would be able to apply the specific attack to urban camouflage environments. So this is the methodology for those people who are methodologically inclined or like a good diagram. But basically, at the end of the day, I'm taking an image of something, so a ship, for example, here. I'm identifying a region in that image or in that sort of that video that is most likely to cause a misclassification, and I test it by applying different kinds of adversarial machine learning methods to that region, testing different models, and then from there I can apply it to lots of different sort of case studies and settings and kinds of objects. And so the point of this specific attack is really that I want to see how I can, instead of having to perturb, say, the actual ship or an object that's being classified, how I can add regions, so distributed regions, to this environment that prevent the model from recognizing what that object is without having to actually change anything about the object. So, for example, if I'm looking at a ship, can I add adversarial buoys around that ship that prevent it from being recognized by image recognition models? And you can. You can do the same for planes and for other kinds of military platforms as well. And the reason that you would want to do something like this, even if you're not actually, even if a human can recognize that maybe something there is a bit different, is because in a lot of settings you don't always have a human in the loop, or you don't have a human in the loop until a lot later in the process. So it's more about disguising something like a platform like this from some sort of automated detection. So because I'm a researcher, unfortunately you have to end up with sort of graphs that look like this as part of the testing process. So what we're really doing is we're testing the extent to which applying these distributed regions to an image are likely to reduce the confidence level of a model in what it's looking at. So, for example, if I were to place some distributed adversarial regions around that ship, it would reduce the confidence that a model has that it's a ship by, say, 40%. And we did find that applying these regions to those sorts of objects decreases the probability by 40.4%. But I'm applying this to casino facial recognition AI. So this is a very unflattering picture taken of me walking up to facial recognition detection. And using this region, I want to try doing things like adding jewelry. Design is maybe to be, could be better. Oh, come on, video. Hang on. I downloaded it over here. So this is what this ends up looking like. So I have a demo here. This is just implementing the attack against one of these open source models. If you're not a code person or you're not really familiar with machine learning code, the point here really is that you can do this in a minute or so. So you don't need to worry too much about what the code represents, apart from noting that we're taking this open source model, we're creating the perturbations based on different targets. This time it's me and my face. I'm testing adding different jewelry around my face, and I want to see if I can prevent that facial recognition model, fine-tuned on images of my face as well, to prevent it from actually recognizing me. So I know this is really exciting, but you have to include a code demo, right? So here it's shown that there's a match found, so that's me testing the clean image of me without any of those perturbations. It was able to find the match, that's that original image. And then I'm going to test the new image, the one with the adversarial regions applied, and we're going to see if there's a match or if it loads. as a spoiler, there was no match. So just does that add to the suspense? I don't know. So I guess we could say that we hacked the AI, right? We were able to prevent it from recognizing me. We certainly want to test it. We want to see the extent to which we're able to decrease the confidence of a model in predicting and recognizing me. And the number that we end up with is, like I said before, 40.4%. So for the images that model was tested on, the confidence in being able to correctly predict what it should be was decreased by 40.4%. So I had a real problem like trying to actually describe this as a hack, you know? I think the challenge in applying cybersecurity kinds of terms and methodology into the world of AI security is that machine learning models are inherently probabilistic. So it's not like you'd necessarily have a binary answer at the end of the day, or you might, but it'd be more scientific to test it multiple times using, you know, the multiple different variables and different kinds of images. So maybe I'm able to prevent that model from recognizing me once, but on the whole, it's more about actually reducing the likelihood that it is able to predict who I am. And the tough thing about applying this to facial recognition is because you're more likely to sort of bound the face. So the model will only look for features within this sort of bounding box in my face, whereas other images are more likely to rely on context. For example, like the water behind the ship helps the model understand that that's a ship. So I kind of hope that it would be better. Like I hoped that it would, you know, the results would be, I don't know, more shocking or more interesting or just more of a hack or an attack. So I was a little bit disappointed. I had to take a pause. I did, you know, what you always do when you want to run away from a problem, and that is I went on a trip, I went to Europe, it was lovely. And then I realized that the problem with my sort of disappointment in the attack was the same problem that I'm always encountering in my work. And that's that most of the organizations that we work with really talk about adversarial machine learning in terms of attacks and defenses. So all the different kinds of attacks that could be employed against a model, and, you know, versus all of the different kinds of defenses that should also be applied to that model. But that's not really the right way of framing it, because in cyber, you don't really talk about cyber attacks versus defenses as, you know, the be-all and end-all. You really talk about maturity and risk. And so an organization has to understand their risk, their highest priority assets and targets, and then decide the priority mitigations, right? And that's not something that is historically talked about in the world of AI security, even though it should be. Like, that's the point we want to mature to. So the questions that we really want to be asking, if we're trying to hack this facial recognition model, is, you know, what is the target? What am I trying to steal? If I'm bypassing a facial recognition AI in a casino context, why is that? And you know, if we're sort of generalizing this and applying this to any organization, that is a question that every organization needs to ask. But if we think about it from the casino context, it really means that, you know, someone is possibly a money launderer or a card counter, and you just want to do that and not be recognized and taken out of the casino. And if that is the goal, maybe go to a casino that doesn't have facial recognition AI. Is the first thing. The next question that we need to ask in this context as well is, like I prefaced before, what does it mean to hack an AI model? It isn't really the right terminology to use if we're thinking about risk in a cyber sense and thinking about all the risks that a system might have in terms of, you know, the system as an attack surface. Just so it's more about the risk that an AI system is going to cause a misclassification rather than the risk of an AI system in its entirety. Because many AI systems can do the same thing, but there currently isn't any regulation or really understanding. There's certainly no requirement to have any research or open source information or closed source information about how robust those models are. So just because a model can perform facial recognition pretty well, all of the different models we tested were extremely variable in how robust they were to to an attack like this. And that's because, as I say here, a machine learning system is inherently probabilistic. It's not deterministic like many of the cyber systems we're used to dealing with. And the last thing, as I've said before, is what are we trying to protect? We're trying to protect the casino's money, their profit, their brand, reputation, all of these things, but thinking about it from the perspective of risk. Because an attack on an AI system is just part of the kill chain, right? It's not like we really think about having one attack that's powerful and able to do everything. It's more about all of the different ways that you could alter this attack depending on your target or the particular case study. And the way I like to think about it is in terms of a Stuxnet style attack versus a DDoS attack. Because many adversarial machine learning attacks tend to fall into sort of a Stuxnet style. They're very cool, they're very complicated, they're able to, deceive an AI system in, I guess, a really cool way, a way that a researcher can be like, this is a cool attack, right? But at the end of the day, it's actually maybe these sorts of attacks that are here that aren't quite so cool to an AI person maybe, but are actually able to disrupt almost all models. Maybe not in the, maybe I'm not able to get the model to think that I'm Angelina Jolie rather than Harriet Farlow, but I'm able to cause a misclassification almost all of the time just by disrupting it. And that is far more likely to have an impact to a casino or to an organization. Because even though that number that was 40.4%, which is a bit disappointing, if you're able to change that attack, if you're able to think about all of the adversarial machine learning attacks that are out there and apply that as part of your existing cyber kill chain, the success rate is 100%. So this is the kind of thinking that needs to happen in the field of AI as well. All of the other sorts of creative ways that you could apply something like a distributed adversarial region in the facial recognition context, things like pimple patches, being able to, if you have access to the actual camera and being able to stick like a clear piece of sticky tape with that adversarial region in it, depending on all of the different points of access you have to a system, those are all things that could be done. The other reason I really like the casino context is because it's all about surveillance, and it's about surveillance by design. And as we're moving as a society to having artificial intelligence that is increasingly being adopted, that's something that we really need to consider because our societies are increasingly becoming surveillance by design. And whether this is a good or a bad thing is, a discussion for lots of people, including, sort of thinking about policy and regulation. But if we think about the casino as an interesting test bed for this, then all of the different ways that facial recognition is being used now in airports for, social credit scoring, for surveillance, for policing, there are all sorts of reports about how minimally robust these models can be. There's no requirement for how robust they need to be at the moment. Because AI security is real. These are some statistics from a company we love, Hidden Layer. They released this report that shows lots of different things about the reality of AI security, but 77% of companies reported identifying breaches to their AI in the past year. This is massive. 96% of IT leaders expressed that their AI projects are critical, which we can all, understand, right? Everyone's talking about AI at the moment. This is a real attack. So even though being able to evade facial recognition AI is possible and scary, at the end of the day, it's in the context of the process that it lies within and the people who are making those decisions in the process that I encourage all of you to think about as well. Even in your roles as cyber people or whatever kind of person you might be, what kind of role you have, it's more about being able to bring all of the different disciplines together so that AI can also mature to the extent that it needs to be, given just how widely it's adopted at the moment. And if we really think about it, I was able to reach out to Casino Canberra through my, PhD. I shouldn't put that in credit. I am a PhD student. And I asked them very kindly if I could go into their casino and sit there and film myself hacking something, and they said yes. So at the end of the day, it's more about the cooperation and, what does it mean to hack an organization, right? So this is a bit of the sort of the theory of these attacks. I'll also be talking about the same stuff at DEF CON. Those talks will go a little bit more into the technical detail of how it worked. I also have another talk at DEF CON in the Policy Village about my experience working in an intelligence agency in Australia, so you can come along and hear all about that too. The things that I'm allowed to talk about, of course. So please do stay in touch. I hope you found this interesting. I think there's some time for questions. I should add, I'm also looking for survey participants for this AI security interview. So if anyone would like to be interviewed, please do.
If you have a question, raise your hand, and I'll bring you a mic.
I was at DEF CON 26 a while ago. They had a similar talk. Does everybody just roll their own, or does there exist an existing package for this DARS?
That's a good question. So, like I said, there's over 100 different kinds of attacks, and a lot of the time they're based on the similar, like the same principles, right? It's an optimization algorithm, and you're optimizing between different constraints. So whether it's trying to affect a misclassification in an image sense, or if you're trying to like cause a specific targeted misclassification, it is all just optimization at the end of the day. So you can easily code it from scratch. But there are pre-existing packages that help you implement adversarial machine learning attacks as well.
Just curious, throughout the course of your research and conducting some of these modifications to like the Jupyter notebooks, was there any attempt or situation where you were able to actually go live with those modifications to the artificial intelligence, or was it just through the modifications of the Jupyter notebook that you were able to see that the image was misclassified?
So to understand your question, whether we're able to test it in like a live environment, not quite yet. We've been sort of conscious of Casino Canberra not really wanting to do that. We are sort of working with some companies that do look at the biometrics and testing some of that now. So for example, the urban camouflage research that we were doing is applying the pixel alterations digitally, but to sort of things like videos. So in theory, you could apply exactly the same pixels in real life, just like those stop sign examples, if you're able to, and you can sort of dynamically alter them as well.
Since you mentioned that surveillance is a big field for this type of technology, do countries try to make bypassing these AI facial recognition tools illegal? Or do they, for me it's currently difficult to imagine to make it illegal, that you are wearing weird earrings, weird hat, etc. But are there movements into that direction, or is it even illegal in certain contexts?
That's a really good question. As far as I'm aware, there's nothing that's illegal about wearing something that could disguise you from facial recognition. The question, I mean, insofar as you're able to exist in a society where it's mandated, I mean, I guess there's nothing stopping you from walking up to the facial recognition AI at an airport and like wearing weird glasses, but then they ask you to take it off, you know? So insofar as you are sort of forced to interact with AI in the various ways that you interact with your life, that's sort of the requirement you have. It would be interesting to see if different jurisdictions did try and regulate something like that. Yeah, I'd be curious to see.
So, yeah, great talk, by the way. That was really awesome. Curious, can you speak to any of the other algorithms that might be used as like layered defense against these like design basis threats, where maybe the lighting in the room modifies the algorithm in some significant way, or other types of behavioral tracking, such as the time of day the person might frequent the casino, the way they walk or any other kind of handicap or other significant item?
Yes, absolutely. So in casinos, they don't really have, well, most of them wouldn't rely on sort of behavioral patterns like that. Other kinds of systems would. So other AI systems that are forced to rely on, time-based decision making or sort of more behavioral information like that. That casinos wouldn't be a case study for that. But where those kinds of systems do rely on other information like that, you could alter the time of day that you frequent a place or change your behavior in some way, just like sort of traditional algorithm hacking. Those models that do rely on pattern of life kind of stuff. I guess that's already... Did I understand your question?
You did. I think there was a good prelude to it. I guess what I'm kind of getting at is do you incorporate other forms of AI or ML to defend the inefficiencies of the facial recognition technology? Would that be kind of the casino secret sauce, so to speak, where they're able to fine-tune the open source algorithms in some way that makes them more effective?
Yes, no, definitely. That's a good question. Yeah, I mean, if a casino were able to incorporate other kinds of decision making to make the facial recognition or the person identification more accurate, that would be ideal. Whether a casino is the right, whether they decide that that's something that's worth investing in based on the potential money they could lose, I think would be, I personally wouldn't know if that cost equation would work out. For fields though, like policing, where it's extremely important that you're able to identify the right person, they do already add other kinds of decision-making intelligence there as well, and there usually is a requirement to as well.
Thank you for the talk. My question was just related to the vectors that you tried. You focused on the jewelry in this talk, and you mentioned sort of those pimple patches. What other sort of mechanisms did you look at? Did you, get a temporary face tattoo? Like, what other sort of things did you consider?
Yeah, I would have liked to try something like that. I think the thing with a temporary face tattoo or something big like that is that it's akin to the DARPA example, where it's not really an AI attack. That's more just about not being as you normally would be. So, I mean, if I were to wear like a ridiculous hat or wear face paint or something, that would obviously also prevent the model from recognizing who I am most of the time. But then is that sort of fair in terms of this research? Probably not. I think the idea is that it's sort of at that boundary where someone could be like, that's some interesting earrings, but not something where someone would really care,
I liked that you kind of highlighted the very grey line between like the fitness for purpose of the algorithm and the ability to quote unquote hack it. Organizationally speaking, who owns this problem? Is it a data science problem or a cybersecurity problem?
Oh, that's my favorite question. Because every organization we work with, that is the question that no one asks. Usually we go in and we find that the executive level thinks that the IT team is handling AI security, that the IT team think that the AI team or the data science team is handling it, they think that the IT team is doing it. No one's doing it. Some people are. But, on the whole, no one's really thinking about it, or the owners are people who don't know a whole lot about it. Often those owners might be cybersecurity people who've been given some rudimentary AI training, and it's great that they're being invested in, but cybersecurity is a very different sort of discipline to AI security, so it's often very hard on those teams. It's a discipline in itself, and there's a lot of crossover between cybersecurity and AI security, but not enough that you can just expect a cyber team to know what to do. So yes, it's a big organizational problem because either organizations think it's not important or it's not a real risk, or they think that their existing teams are fully capable of dealing with it, or they're just not sure that's the right thing to do. So it's a good question.
All right, that just wraps it up. Thank you, everybody.
Thank you, everyone.